In the stillness of a starless night, far beyond the comfort of our familiar skies, there lies a deep and boundless darkness. Imagine yourself drifting quietly through the silent void of space, surrounded by endless night. The darkness here is profound, almost tactile, wrapping around you like a soft velvet blanket. There are no nearby planets, no glowing moons or bright city lights, only the gentle shimmer of distant stars, like tiny islands of light in a vast sea of dark. Their faint glow speckles the cosmic ocean, offering points of reference in an otherwise unbroken expanse of black. In this tranquil emptiness, you feel a mix of wonder and peace. The silence of space is absolute. You can almost hear your own heartbeat echoing in eternity. The universe around you is hushed and mysterious, an ancient darkness stretching in all directions, serene and infinite. For as long as humans have looked up at the night sky, we have been both fascinated and comforted by the darkness dotted with stars. In the quiet of a clear night, away from city lights, one can lie back and gaze upward, feeling the infinite depth of the darkness above. It can feel peaceful, like a time for dreams and contemplation. Ages ago, our ancestors saw the night as the realm of the unknown, perhaps even home to gods or spirits. They wove stories about the figures they imagined among the stars and wondered what lay in the black voids between. Little could they have known how strange and wonderful the truth would be, that the darkness itself holds the majority of the universe's substance. Now we know that darkness is not an emptiness at all. It is full of its own subtle substance and secrets. To the peoples of old, that darkness was the abode of mystery and divinity. They never imagined that the reality of that darkness would turn out to be even more exotic. Not a void, but a rich tapestry of invisible matter and energy. Yet in that darkness, there is presence. Invisible and silent, it makes itself known not by light, but by its pull, the gentle tug it exerts on everything around it. This is the hidden essence that scientists poetically call the dark side of the universe. It's not a literal dark side, like a shadow on a wall, and it's certainly not a place of evil or fear. Rather, it is a way to describe all the parts of reality that are unseen, unknown, yet profoundly important, in the same way that the ocean's depths are dark to us, but full of unseen life and currents. The universe's darkness is rich with invisible influences. As you float through the cosmic night, you might sense that most of what surrounds you cannot be perceived with your eyes or any of your other senses. And indeed, modern astronomy tells us that the majority of our universe is composed of this invisible substance and enigmatic energy. They quietly shape the cosmos in ways we are only beginning to understand, weaving an expansive cosmic tapestry where the luminous threads are supported by a vast unseen fabric. Gently, we begin our journey through these unseen realms. Let us explore this cosmic darkness together, slowly and calmly, as if we have all the time in the universe. There is no need to rush out here in the starlit void. The story of the cosmos unfolds on timescales far beyond human lifetimes, and we have the luxury of moving through it at a relaxed, drifting pace. We will drift among galaxies and through the great silent voids between them. We will listen to the quiet stories of hidden matter and phantom energy. With each passing moment, we peel back one more layer of the mystery, unhurried and in awe at the scale and beauty of it all. If your mind ever feels lost or overwhelmed, Simply imagine that you are floating gently on a cosmic breeze, letting the stars and galaxies pass by like distant lanterns in the night, as we softly speak of the secrets that lie in the dark. Our voyage starts with a simple, profound truth. When we gaze into space, what we see, stars, planets, glowing nebulae, luminous galaxies, is only a tiny fraction of what is really there. Our eyes, even aided by the most powerful telescopes, catch only the bright tip of a great cosmic iceberg. The light of those stars and galaxies is breathtaking, to be sure, but behind and between that light is something immense and largely invisible. It has been said that the visible universe, everything from the faint gleam of a firefly on Earth to the brightest galaxy at the edge of the cosmos, is like the foam on the crest of a vast, dark sea. That dark sea is the unseen universe, the subject of our journey. We often call it the dark side of the universe, not to imply anything sinister, but simply to mark how little light it gives off. It is dark because it does not radiate or reflect light in any familiar way. It hides in plain sight, detectable to us only by the subtle ways it tugs on the things we can see. Indeed, astronomers now estimate that all the stars, gas, and galaxies we see make up less than 5% of the cosmos. The rest is dark. To get a sense of what this means, imagine looking at a beautiful spiral galaxy, perhaps similar to our own Milky Way. Its broad disk of stars swirls like a cosmic pinwheel against the blackness of space, spiral arms glowing with the light of billions of suns. Clusters of young blue stars light up gas clouds in those arms, and older, mellower stars crowd the central bulge. You might think that all of the galaxy's substance lies in those glittering stars and the delicate traces of glowing gas. That was certainly the natural assumption for a long time. But if you could weigh this galaxy, as astronomers have learned to do, you would discover something astonishing. The starlight and glowing gas account for only a small part of the galaxy's mass. There is far more mass present than meets the eye. Wrapped around and threading through the galaxy is an enormous halo of something utterly dark, something that neither shines nor reflects light, something invisible except for the way its gravity influences the motions of the stars and gas. This hidden mass is what holds the galaxy together, preventing those majestic, spinning arms from flying apart into space. Astronomers have given this mysterious substance a humble name: dark matter. Dark matter is our first destination on this journey into cosmic darkness. It is a term that sounds simple, yet it represents one of the deepest mysteries in astrophysics. To call it dark is to say it does not glow or reflect light. To call it matter is to say it has gravity, it has mass, and it influences other matter as any mass would. But what exactly is it? To explore that, we will travel back in time to when hints of this mystery first emerged in human knowledge. We move gently through decades of discovery, to a time when the universe's composition was a little less understood, and scientists were just beginning to notice that something important was missing from the picture. It is the early 20th century. In a quiet mountainside observatory beneath a canopy of crystal-clear stars, an astronomer peers through his telescope at a far-off cluster of galaxies. The year is 1933, and the astronomer, Fritz Zwicky, is studying the Coma cluster, a vast swarm of galaxies bound together by gravity. He measures how fast these galaxies are moving, each one whirling in the cluster's gravitational embrace, like fireflies caught in a slow whirlwind. What he finds is puzzling. A whisper from the unseen depths of the universe. The galaxies are dancing around each other far too quickly. So quickly, in fact, that if only the visible matter were holding them together, the cluster should have flown apart, scattering its galaxies into the surrounding void. The gravity from all the stars and gas we can see simply isn't enough to keep the cluster intact at those speeds. To Zwicky, the sensible conclusion is startling. There must be much more mass in this cluster than meets the eye. Some enormous additional source of gravity, some hidden mass, is providing the glue that binds the galaxies together. This was a daring idea for its time. Zwicky, bold and unafraid to challenge convention, gave this unseen mass a name, Dunkel Materie, which is German for dark matter. By dark, he meant invisible, matter that does not emit or reflect any light, yet exerts gravitational pull. He spoke of it plainly, as if identifying an object in the room, yet what he was suggesting would one day revolutionize our understanding of the cosmos. At first, his peers didn't quite know what to make of it. The notion that vast amounts of matter could simply be unseen was intriguing, but also met with skepticism. Astronomy, after all, is a science of observing light, from stars, nebulae, galaxies. If something doesn't emit light, how could we be sure it's there? For a time, dark matter remained a shadowy hypothesis, hovering on the edges of astrophysical discussions. Zwicky's calculations, while compelling, were not enough on their own to convince everyone. It was as if he had heard a faint cosmic melody that others had not yet tuned into. Decades passed. The idea of dark matter lingered in the background, neither confirmed nor refuted, waiting for more evidence. We drift now to the 1970s, under the clear night skies at observatories in the Arizona desert. There, another astronomer, a pioneering woman named Vera Rubin, is quietly gathering the evidence that will bring dark matter to the forefront of science. Night after night, Rubin and her colleague, Kent Ford, point their telescopes at spiral galaxies, including our neighbouring galaxy Andromeda and many others. Rubin measures how fast stars at various distances from each galaxy's centre are orbiting around it. Using a spectrograph, she observes the slight shifts in the star's light due to their motion, using the Doppler effect, similar to how a siren's pitch changes as it moves. What Rubin finds is astonishing and unmistakable. In galaxy after galaxy, the stars at the very edges, far from the brilliant galactic core, are moving just as fast as the stars closer in. To put this in perspective, consider our own solar system. The inner planets, like Mercury and Venus, whirl around the Sun much faster than the outer planets, like Jupiter and Neptune. This is because the gravity holding them in orbit comes mostly from the mass of the Sun at the centre, and the further out you go, the weaker the Sun's pull becomes, so the orbital speeds drop off. By analogy, one would expect stars on the outskirts of a galaxy to orbit more slowly than those near the crowded centre, if almost all the mass were concentrated in the visible stars and gas in the galaxy's core. But Rubin's observations defied that expectation. The outer stars were not moving slower at all. Their speeds had levelled off, creating what astronomers call a flat rotation curve. In some cases, stars far out in a galaxy were moving even faster than some closer in. It was as if an unseen gravitational force was whirling those outer stars along, giving them extra tug to keep pace with the inner stars. Such a result was thrilling and profound. Rubin's data piled up quietly at first. One galaxy, then another, then dozens, all telling the same story. The conclusion became inescapable. The visible material in these galaxies, the stars, gas, and dust that shine or glow, was only a small portion of what was there. Each galaxy must be embedded in a vast halo of dark matter, extending well beyond the visible edges of the galactic disk. This dark halo provided the gravitational pull needed to explain the fast-moving stars on the outskirts. In the late 1970s and into the 1980s, Rubin published these findings, and the astronomical community embraced this reality that had been hiding in plain sight. By the early 1980s, dark matter had gone from a contentious idea to a central component of our cosmic understanding, a revolutionary shift in perspective. These observations were like listening to a quiet, cosmic whisper that grew into an undeniable chorus. There is more out there than meets the eye. Zwicky's earlier hint had grown into a robust, loud signal through Rubin's work. It was as if the universe had slowly turned a key, opening a door to the vast dark domain that constitutes most of the matter in existence. Faced with this mountain of evidence, astronomers had to accept that every galaxy, including our own Milky Way, is nestled in a huge cocoon of dark matter. This halo of invisible mass envelops the galaxy and far outweighs the mass of all the stars within. The dark matter halo cradles the galaxy, its gravity guiding the motions of stars and gas, holding the galaxy together in its cosmic dance with a firm yet unseen hand. Pause for a moment to picture that in your mind's eye. Our Milky Way galaxy, a broad disk of hundreds of billions of stars, is like a glowing spiral floating in space, a luminous pinwheel in the darkness. Now envision a great, invisible sphere enveloping it, a halo much larger than the galaxy itself. This dark halo stretches out beyond where any star or gas cloud can be seen, surrounding the Milky Way in every direction. If somehow we could make this dark matter halo visible, our galaxy would appear enormous. Not just a flat spiral, but a vast, faintly glowing ball with a bright spiral at its heart. The halo might extend several times the radius of the visible galaxy, making the Milky Way look like a tiny jewel nested deep inside a diffuse, gigantic bubble. This sphere is the dark matter halo. It doesn't shine or glow. If you were floating just outside the galaxy, you would not see this halo at all, no matter how you strained your eyes. But you would feel it subtly in the motions of stars around you, the way a sailor senses an invisible current beneath a calm sea, or a pilot feels the air currents while flying at night. Each star, even at the far edge of the Milky Way, is held in the gravitational embrace of this halo. The star might not know what holds it, much as we might not feel the air's pressure until a breeze blows, but it is bound all the same. In the darkness, an unseen mass is gently pulling, binding the galaxy together, and yet this dark matter is not distant or separate from us. It is all around us, right here on Earth and throughout our own lives, unnoticed. Even as you lie here listening to this gentle exploration, there are likely dark matter particles flowing through you, through the room around you, through the very crust of the Earth beneath you, countless millions of them each second, if current theories are correct, and you do not notice them at all. They pass through without a trace, like ghosts in the night, seldom interacting with the atoms of your body or anything else. To our senses, they are completely transparent. It's a strange, almost magical thing to imagine. We are bathed in an invisible, intangible sea of dark matter as the Earth journeys around the Sun and the Sun orbits our galaxy. We've actually known for some time that particles can exist which barely touch the rest of matter. Take neutrinos, for example, tiny neutral particles produced in the heart of the Sun and in cosmic ray interactions. Billions of neutrinos stream through your body each second, and you never feel them. They slip through the Earth as if it weren't even there, with only the rarest interactions. Scientists have built large underground detectors to capture just a few of these neutrinos. For instance, in one such experiment in Japan, a vast tank filled with ultra-pure water is lined with thousands of sensitive light sensors, waiting in silence. When a neutrino from the Sun or a distant supernova happens to collide with an atom in that water, it produces a tiny flash of light, and those sensors capture it. These rare detections confirm that neutrinos, essentially invisible and untouchable to us, are nonetheless real and passing through us in tremendous numbers. It's direct evidence that the invisible can exist all around us. Dark matter, if made of weakly interacting particles, would be even more aloof than neutrinos, interacting even less frequently. So it isn't so unbelievable that an ocean of particles could surround us unseen. We already live immersed in one kind of ghostly particle field, and dark matter would be an even quieter sea. We truly are, in a sense, submerged in the dark side of the universe as we go about our daily lives, completely unaware. It's a humbling thought that most of the matter, even here in our own vicinity, is invisible to us. Yet it has been part of our world from the very beginning, silently guiding the formation of our Sun, our planet, and the stars beyond. Now, gently, we wonder, what is this dark matter actually made of? We know it's there because of its gravitational pull, but if we reach out and try to touch it, our hands close on empty space. It's as if we're grasping at a shadow. It does not collide with us or with the walls of our laboratories. It does not emit light or energy that we can detect. It leaves no mark on photographic plates or even on the most sensitive digital cameras. It moves through us as if we weren't there, and through it, we move as if it weren't there. Over the years, scientists have proposed various ideas to explain what this elusive substance could be. Each idea is like a small lantern, attempting to light up one corner of a vast, dark room, hoping to catch a glimpse of the shape of the thing we seek. A few scientists even proposed that maybe no new matter was needed at all. Perhaps gravity itself behaves differently on the scale of galaxies. If the laws of gravity changed over large distances, they argued, it might produce the effects we see without invoking invisible mass. This notion of modifying gravity, sometimes called MOND for modified Newtonian dynamics, could indeed explain some galaxy rotation curves by tweaking how gravity works at low accelerations. However, such ideas faltered when confronted with the full range of evidence. The motions of galaxy clusters, the gravitational lensing patterns in events like the Bullet cluster, and the detailed patterns in the cosmic microwave background. Those phenomena still demanded some form of unseen mass. So today, the vast majority of researchers are convinced that dark matter is real. There is something out there to be found, even if we don't yet know exactly what it is. One leading hypothesis is that dark matter could be a new kind of elementary particle, something outside the familiar family of protons, neutrons, and electrons, and even beyond the ghostly neutrinos we already know. Among these hypothetical particles, a popular candidate has been whimsically named the WIMP, which stands for Weakly Interacting Massive Particle. This name captures the idea well. If dark matter consists of WIMPs, then each particle would be massive, meaning it has weight and contributes to gravity. But it interacts only very weakly with normal matter, meaning it almost never collides or produces light. In many theories, these WIMPs would be heavier than protons, perhaps dozens or hundreds of times heavier, making them quite hefty on the subatomic scale. Yet their presence would be nearly impossible to detect except through gravity. Trillions of WIMPs could be streaming through your body at this very moment, and you'd never know. The concept of such particles isn't just pulled from thin air. Some extensions of physics theories, like supersymmetry, which goes beyond the current standard model of particle physics, naturally predict particles with the right properties to be dark matter. For a long time, WIMPs were the favoured darlings of dark matter research, and many experiments have been designed to find them. Imagine, deep underground in an old mine, or beneath a mountain, scientists have set up large quiet detectors to listen for the faintest whispers of dark matter particles. These detectors might be vats filled with ultra-pure liquid xenon, or arrays of chilled crystals of germanium or silicon. They are shielded by rock from the noisy shower of cosmic rays that constantly rain down on Earth's surface. In the stillness of these subterranean chambers, a WIMP particle, if they exist, might occasionally smack into the nucleus of an atom in the detector. Such a collision would be exceedingly rare. A single particle might fly through 1,000 kilometers of solid lead without ever hitting anything. But if one does strike just right, it would make a tiny flash of light or a subtle vibration in the detector. The scientists wait patiently, year after year, monitoring their instruments for these potential 1-in-a-million events. It's a bit like sitting in a dark, silent room, waiting to see if a single firefly will wander in and blink once. So far, these experiments have not conclusively seen a WIMP's blink or tap, but they have managed to rule out many possibilities, narrowing down the properties that WIMPs, if they exist, might have. The search continues in deep, calm silence, much like our journey here, quiet, persistent, and hopeful. WIMPs are not the only idea. Another intriguing candidate is something called an axion. Axions, if they exist, would be extremely lightweight particles, far lighter than even electrons. Instead of acting like individual specks, axions would behave more like a field that permeates space, somewhat like a gentle, all-pervading wave or wind. In enormous numbers, these lightweight particles could collectively provide the mass needed for dark matter. Axions were originally proposed for other reasons in particle physics, to solve a problem with the theory of the strong force. But scientists realized they could also fill the role of dark matter. They have an almost ethereal quality in theory. One extraordinary property axions might have is the ability to very occasionally convert into a particle of light, a photon, in the presence of a strong magnetic field. Utilizing this idea, some experiments employ powerful magnets and sensitive radio receivers, hoping to catch the faint whisper of axions turning into radio waves. So far, no definitive signal has been heard. But the search is ongoing, and the idea remains compelling enough that it continues quietly in the background of dark matter research. Others have wondered if dark matter might be related to neutrinos, the little neutral ones we discussed earlier. We know normal neutrinos exist in great abundance, produced in nuclear reactions in stars and during supernova explosions. But the ones we know are too lightweight and speedy to make up dark matter. They zip around at near light speed and wouldn't clump into galaxies. However, there might exist heavier, slower cousins of the neutrino that interact even more weakly. These hypothetical particles are often called sterile neutrinos. Sterile because they wouldn't even engage with normal matter via the usual weak nuclear force that regular neutrinos do. They would only feel gravity, and perhaps mix subtly with normal neutrinos. If such particles exist, they could contribute to dark matter. They might even decay occasionally into lighter particles, which some X-ray telescopes have tried to detect as a faint glow at specific X-ray energies coming from galaxies. The evidence for this is tantalizing but not yet conclusive. Some studies see a hint of an unexplained X-ray line that could be from sterile neutrino decay, while others are not sure. Sterile neutrinos remain on the list of suspects, an intriguing possibility that scientists keep in mind while sifting through cosmic signals. And what if dark matter isn't a new particle at all? Some have proposed more exotic possibilities. One idea is that dark matter could be made of primordial black holes, tiny black holes that might have formed in the high-energy chaos of the infant universe long before stars and galaxies. Black holes, by their nature, emit no light except perhaps faintly via Hawking radiation, especially if they are small. So a swarm of primordial black holes could act as dark matter, hidden in the darkness, unless they reveal themselves through gravitational effects. For a while, people wondered if the mysterious dark matter might in fact be these unusual invisible objects. However, as astronomers looked for signs of such black holes, for example the way their gravity might bend the light of background stars, a technique called gravitational microlensing, or how they might disrupt stellar systems, they found no evidence that enough of them exist to account for all of the dark matter. Observations have largely ruled out primordial black holes as the main form of dark matter, except possibly in certain narrow size ranges. It appears that only a very limited portion of dark matter, if any, could be in the form of these hidden black holes. Still, it's fascinating to consider that even the concept of dark matter has led us to ponder things as strange as tiny black holes wandering the galaxy. As we can see, there is no shortage of creative ideas, each potential candidate for dark matter, be it WIMPs, axions, sterile neutrinos, primordial black holes, or something even more exotic, is an attempt to solve the riddle of this great cosmic ghost. Scientists worldwide have united in this quest, using different techniques. Deep underground detectors listening for those faint particle taps, high-altitude balloons lofting instruments above the atmosphere, space telescopes scanning the heavens for subtle signals, and giant particle colliders recreating conditions of the Big Bang in miniature. In those colliders, like the Large Hadron Collider in Switzerland, researchers smash particles together at enormous energies, hoping that in the aftermath, some energy might disappear into the creation of invisible dark matter particles. If that happened, it would appear as an unexplained missing energy in the debris of the collision, another possible telltale sign. So far, no clear dark matter particle has shown itself in these experiments, but each null result helps refine our understanding, like narrowing the search area on a vast map. All these ideas float in the scientific imagination like distant constellations of possibilities, each offering a faint glimmer of hope to illuminate the darkness. As of now, the true identity of dark matter remains one of the great unanswered questions in physics and cosmology. Still, while we may not yet know what dark matter is in the microscopic sense, we have learned a great deal about what dark matter does in the grand scheme of the cosmos. We know how much of it there is, about 5 times as much mass as ordinary matter if our measurements are correct. We can map where it is, surrounding galaxies, forming the scaffold of galaxy clusters, threading the universe in an enormous network. In other words, while the true nature of dark matter remains unknown, we do know how this invisible mass behaves on large scales. Look again at that spiral galaxy we imagined earlier, its stars orbiting in the steady grip of a vast halo of dark matter. Now, imagine many such galaxies, hundreds of them, collected together in a cluster. These clusters of galaxies are among the largest structures bound by gravity in the universe. Here too, dark matter reigns. In a galactic cluster, galaxies swarm like bees around an unseen hive. Their movements reveal that the hive, the deep gravitational well of the cluster, is largely composed of dark matter. The visible galaxies are like a sprinkling of bright dust, tracing out the deep gravitational potential created by dark matter's bulk. A dramatic piece of evidence for dark matter's dominance in clusters came from observing a cosmic collision known as the Bullet Cluster. Here, two massive galaxy clusters crashed into each other at tremendous speed, a collision that took place hundreds of millions of years ago. In the aftermath, astronomers observed something remarkable. The hot gas that makes up much of the normal matter in clusters, and which shines brightly in X-rays, had slammed together and slowed down, piling up near the center of the collision like two clouds of smoke meeting and merging. But the galaxies, and crucially the dark matter, sailed through the collision mostly unimpeded. Using a technique called gravitational lensing, where the gravity of mass bends the path of light from background galaxies, scientists mapped out where the mass ended up after the crash. They found that most of the mass, inferred by how it bent background light, was no longer aligned with the visible hot gas, the ordinary matter. Instead, the mass had moved ahead. In other words, the main gravitational pull was coming from regions that had separated from the normal matter. The hot gas from each cluster, which interacts electromagnetically, had been slowed and left behind, whereas the dark matter, which interacts hardly at all except through gravity, had passed straight through. The galaxies, being relatively small and far apart, also mostly passed through each other, their stars not colliding, because of the vast distances between stars. After the collision, the galaxies and the dark matter halo from each cluster ended up on the far side of the impact, while the X-ray bright gas was stuck in the middle. Take a moment to absorb what that means. Even in one of the most titanic crashes in the universe, the dark matter slipped through the chaos like a silent ship in the night, while normal matter, the hot gas, blazed, interacted, and ground to a halt. This observation was a stunning confirmation that dark matter is a separate component and behaves differently from normal matter. It was almost like a natural experiment on a massive scale. The stars and galaxies mostly ignored each other and kept going. The dark matter, invisible but mapped by gravitational lensing, also kept going. But the normal matter, the gas, clashed and stayed behind. Gravitational lensing, in fact, has become one of the most powerful tools for studying dark matter in such situations. Many massive clusters of galaxies act like cosmic lenses, bending and distorting the images of background galaxies into arcs and smeared shapes. By carefully analyzing these distorted arcs, astronomers can deduce where the mass is distributed in the cluster, effectively creating a map of the unseen dark matter. Over and over, these maps have revealed that the majority of the mass in clusters extends well beyond the visible galaxies and hot gas, tracing out the footprint of an extensive dark matter halo. It's a beautiful confirmation. We are able to see the influence of dark matter through the way it bends light, even if we can't see the dark matter itself. Observations like the Bullet Cluster and others have given us great confidence that dark matter is truly there in enormous quantities, silently shaping the cosmos. Now let us drift out even further, to the biggest scales of all, where we can see not just clusters of galaxies, but the grand pattern of galaxies across the universe. If we could pull back far enough until galaxies themselves appeared as tiny points of light, we would notice that these points are not scattered randomly. Instead, they form a vast cosmic web, a pattern of filaments and nodes, almost like the threads of a spider's web, or the filaments of some cosmic neural network, spread over unimaginable expanses. Galaxies are concentrated along these thin web-like filaments, and at the intersections of filaments lie clusters and superclusters of galaxies. Between these filaments stretch enormous voids, great bubbles of space with hardly any galaxies at all, where darkness reigns nearly undisturbed. This cosmic web is the large-scale structure of our universe. It is the scaffolding on which galaxies are hung, and once again, it is the handiwork of dark matter. Long ago, in the very early universe, matter was spread almost uniformly, but not perfectly so. There were slight densifications and rarefactions, like the subtle ripples on the surface of a pond. Because dark matter does not interact with light or radiation, it was free to start clumping together, even when the rest of the universe was a hot, glowing plasma. As the universe expanded and cooled, these subtle concentrations of dark matter grew denser, drawing in more and more mass with their gravity. Ordinary matter, primarily hydrogen and helium gas at that time, was pulled into these dark matter concentrations, like dust settling into the valleys of a landscape. Over billions of years, those invisible gravitational wells turned into the filaments and clumps we see now as the cosmic web. The ordinary gas collected in these dense areas and eventually cooled enough to ignite as stars, and galaxies formed where the dark matter density was highest. Over time, the first galaxies clustered and grew, tracing out the same pattern that dark matter had already established. In essence, dark matter created the blueprint for where galaxies and clusters would emerge. Even now, every galaxy shines from within a larger nest of dark matter that provided the gravity to bring it together. We cannot see the dark matter filaments directly with our eyes, but if somehow they glowed, the night sky would reveal a breathtaking structure, a faint lattice of light stretching across the cosmos. Galaxies would outline the threads of this web, like dewdrops catching morning light on a spider's web. In reality, we infer this structure through galaxy surveys and computer simulations rather than direct sight. But it's humbling to think that an intricate network of the invisible underpins the arrangement of everything we do see. Imagine yourself floating in one of those voids now, those immense black cavities between the filaments of galaxies. You are in a place of almost unimaginable solitude and darkness, with the nearest galaxy millions of light years away, a tiny, faint smudge of light in the distance. It would be a realm of stillness and near-perfect quiet, a vast gulf where perhaps only a handful of galaxies might be found in an enormous volume of space. Yet even there, dark matter is present. The void isn't completely empty. A few stray atoms might drift through each cubic meter, and dark matter particles too, though both are far more sparse than in a filament or galaxy. In time, perhaps tens of billions of years, a thin stream of matter might drift through, or a small galaxy might fall in from a neighboring filament. But for now, the void remains one of the universe's quietest neighborhoods. By contrast, if you float near a filament, you would gradually feel the pull of gravity guiding you toward a grand strand of clustered galaxies, as if you were on a gentle slope in the fabric of space that leads towards the nearest concentration of mass. And what of the ordinary matter, the kind we are made of? The protons, neutrons, and electrons, the atoms that form stars and planets and people. Interestingly, even most of that normal matter does not shine in stars. Much of it resides in darkness as well. Astronomers call this the missing baryon problem, baryon being the term for particles like protons and neutrons, i.e., normal atomic matter. When scientists calculated how much normal matter should exist based on conditions in the early universe, using measurements of the cosmic microwave background and the ratios of light elements formed shortly after the Big Bang, they found that about half of that predicted matter was unaccounted for in stars, galaxies, or hot gas clouds. It was as if half of the ordinary matter in the universe had gone missing, hiding somewhere beyond our view. In recent years, through sensitive observations and clever techniques, astronomers found clues that these missing baryons lurk in immense, diffuse filaments of gas stretching between galaxies, something known as the warm-hot intergalactic medium, or WIM. This gas is extremely tenuous, spread thinly across space, making it nearly impossible to detect directly. But by looking at the light of distant quasars, extremely bright galaxy cores, shining through these voids, astronomers detected subtle absorption lines, a hint of this sparse gas absorbing certain wavelengths of light. Later, space telescopes sensitive to X-rays picked up a faint whisper of a glow from this hot, thin plasma. Bit by bit, evidence mounted that the missing ordinary matter was hiding in these wispy intergalactic bridges, heated to millions of degrees, yet so dilute that it emits only a weak signal. In these wisps, the missing baryons were found, confirming that normal matter too often dwells in darkness, spread out in the space between galaxies. All around us then, from the scale of galactic arms to the span of cosmic filaments, dark matter and other hidden forms of matter provide an unseen backdrop. They silently support and shape the luminous things we see. By now, multiple lines of evidence have independently pointed to the existence of this dark matter. We see its effects in the rotation of galaxies, in the motions of galaxy clusters, in the bending of light by massive structures, and even in the subtle patterns of the Big Bang's afterglow. Everywhere, the story is consistent. An invisible form of matter dominates over the visible. In fact, detailed measurements of that ancient afterglow, the cosmic microwave background, by satellites have allowed cosmologists to measure the universe's recipe with precision. Only about 5% of the universe's content is normal atomic matter. Roughly 27% is dark matter, and the remaining 68% is something even more mysterious: dark energy, which we will discuss shortly. The ancient light of the cosmic microwave background itself carries the imprint of these invisible components, further affirming their reality. It brings to mind a gentle metaphor. Think of a vast, dark ocean at night, with a few scattered lights from boats and perhaps the reflection of stars on the waves. The lights are the galaxies and stars, beautiful and attention-grabbing. But beneath those lights lies the enormous dark ocean water, which supports and connects the boats. That ocean water is like the dark matter, supporting and interacting with the lit surfaces in fundamental ways that are not immediately visible. And even the air above the sea, the thin, barely visible, ordinary gas that drifts between galaxies, is part of the story, like a faint mist that one can easily overlook. Now, having spent some time among the mysteries of dark matter and the hidden scaffolding of the cosmos, let's step back and appreciate where we are in our journey. We have explored the idea that all the stars, planets, and glowing nebula, everything we consider the visible universe, are only a small part of what's truly out there. We drifted through halos of invisible mass, felt the gravitational presence binding galaxies, and saw how dark matter formed a cosmic web that underlies the very structure of the universe. We even discovered that ordinary matter has its own hidden side, spread thinly in the darkness between galaxies. It is as if we walked through a dark forest with a lantern and discovered that the shadows conceal more trees than the light ever showed, and even a fine mist in the air, the whim gas, was part of the scene. In the soft darkness of this contemplation, a gentle question forms. Is dark matter the entirety of the dark side of the universe? The answer, it turns out, is no. As if one grand cosmic mystery weren't enough, there is another, even more pervasive darkness to explore. For while dark matter makes up roughly 27% of the universe's contents, scientists have discovered that about 68% of the universe is something else entirely, something we call dark energy, which is even more enigmatic. The stars, galaxies, and all the visible and otherwise ordinary matter are less than 5%. It's as though we had been focusing our eyes on a small cluster of lights in a vast dark cavern, and now realize that not only is the cavern filled with unseen mass, dark matter, but the cavern itself is expanding, pushed open by an unseen pressure, dark energy. So now, we transition gently from talking about matter, dark and light, to the realm of energy and the grand mystery of the accelerating universe. It turns out there is indeed another chapter to this story of cosmic darkness. Before dark energy was discovered, scientists thought they had a reasonably good grasp of how the universe's expansion should behave. Ever since the work of Edwin Hubble in the 1920s, we have known that the universe is expanding. Space itself is stretching, carrying galaxies apart from one another, like raisins embedded in rising dough. It seemed logical that this expansion would be slowing down over time. After all, gravity is an attractive force, the combined gravity of all the matter in the universe, galaxies, gas, dark matter, everything, should be pulling against the expansion, trying to break it. The big question for much of the 20th century was, will the expansion continue forever? Or will it someday halt and reverse into a big crunch? If the universe had enough matter, and thus enough gravity, perhaps eventually the expansion would slow, stop, and turn into a contraction, leading all galaxies to come crashing together in a fiery end. If there was too little matter, the expansion might continue forever, but at an ever-decreasing rate, asymptotically approaching a standstill, but never quite stopping. By the late 1980s and early 1990s, many scientists leaned toward the idea that we lived in a universe that would expand forever, but gradually slowing down due to gravity's pull, like a cosmic explosion that's slowly running out of steam. To test this, astronomers devised a plan to measure the history of the universe's expansion. They looked for standard candles, objects of known brightness that could be seen across vast distances. One of the best standard candles known is a kind of exploding star called a Type Ia supernova. These supernovae occur under specific circumstances. For instance, when a white dwarf star in a binary system accretes too much matter from its companion and reaches a critical mass, causing a runaway thermonuclear explosion. Because the mechanism of these explosions is fairly uniform, Type Ia supernovae have nearly the same intrinsic brightness, like light bulbs of the same wattage. By comparing how bright they appear to us with how bright we know they truly are, we can determine their distances. And by measuring how much their light has been redshifted, stretched to longer wavelengths, by the expansion of space during its journey to us, we can infer the expansion rate of the universe at the time the supernova exploded. In the 1990s, two teams of researchers scattered around the globe took on the challenge of observing these incredibly distant, faint supernovae. It was meticulous work. They had to scan patches of sky, often using large telescopes, to find points of light that suddenly appeared or brightened, signals of supernovae in distant galaxies. Once found, these supernovae had to be monitored over weeks as they brightened and then faded to determine their peak brightness. By analyzing their light, scientists could tell they were type Ia and gauge their intrinsic luminosity. They gathered data from supernovae billions of light years away, whose light left them long before our sun even existed, and whose faint glimmer was now being captured by sensitive detectors. The expectation was that these far-off supernovae would show the signs of a decelerating expansion. They would appear a bit brighter, and thus closer, than they would in a constant expansion, because the universe's expansion should have been faster in the past and slower now, meaning those galaxies wouldn't be as far as they'd be under a constant expansion scenario. But when the data came in, the results were the opposite of what anyone expected. The distant supernovae were dimmer than anticipated, meaning they were farther away than our best models predicted. In other words, the expansion of the universe hadn't been slowing down over time. It had been speeding up. Distant galaxies were more distant than they should have been if gravity was steadily slowing the expansion. This could only mean that the expansion of the universe has been accelerating. Initially, the astronomers themselves did not believe it. They spent months checking and rechecking their results, trying to find errors. This was such a surprise that one scientist famously compared it to throwing a ball up in the air and having it speed up and fly away, rather than slow and fall back to the ground. But gradually, as more supernovae were observed and alternative explanations were ruled out, the reality set in. Beginning a few billion years ago, the expansion of the universe started accelerating and has been accelerating ever since. This discovery landed softly in scientific journals in 1998, but it shook our understanding of the cosmos to its core. In 2011, the leaders of those two supernova teams were awarded the Nobel Prize in Physics for this finding. To explain the unforeseen acceleration, scientists invoked a new component of the universe, something that had been lurking in Einstein's equations and in theoretical discussions, but never definitively observed. Something we now call dark energy. The name itself is a placeholder, dark, because, like dark matter, it's something we cannot see or detect directly in the lab. And energy, because it doesn't clump like matter, but rather seems to be tied to the very fabric of space. In essence, dark energy acts like a sort of pressure or tension in empty space that causes space to expand. The idea of an energy inherent to space isn't entirely new. In fact, back in 1917, Albert Einstein introduced a term in his equations of general relativity called the cosmological constant, essentially a constant energy associated with space itself. He did this to allow for a static universe, because at the time, The prevailing thought was that the universe was neither expanding nor contracting. When Hubble discovered the expansion, Einstein reportedly removed the cosmological constant, calling it his biggest blunder. One can only imagine Einstein's surprise had he lived to see 1998, when astronomers found that such a force is actually needed to explain our universe. Little did he know, his cosmological constant was not a blunder at all, but a prescient inclusion, something very much like it is required to explain the accelerating universe. Dark energy in its simplest form is essentially Einstein's cosmological constant revived, a small, constant energy density filling space. One way to visualize dark energy is to imagine that even the emptiest vacuum of space has a sort of faint pressure or springiness built into it. When there's more space, there's more of this push, causing space to expand further. It's a bit like having an elastic fabric that, once stretched, has a tendency to stretch further on its own. As space expands, more space comes into existence, and thus more dark energy manifests, which then drives even more expansion. A kind of runaway effect, though extremely gradual. The key is that this effect is very slight on small scales, or over short times. Within galaxies, or even galaxy clusters, gravity easily overwhelms dark energy, so these structures don't fly apart. But over the vast reaches of intergalactic space, where gravity gets very weak, dark energy's influence becomes significant. To give a sense of how subtle dark energy is, if you took a region of space about the size of your living room, the amount of dark energy in that volume might be equivalent to the mass of a tiny grain of dust, or maybe even less. Completely negligible, but space is not the size of a room. It's effectively infinite and ever-growing. Over truly colossal distances, millions upon millions of light years, the small repulsive effect of dark energy adds up to overcome gravity. The result is that today, dark energy constitutes roughly 68% of all the energy in the universe. It's everywhere, woven into the fabric of space-time itself, quietly pushing the cosmos to expand faster and faster. What does an accelerating universe mean for the future? If dark energy continues to behave as it does now, as a constant energy density of space, the universe will keep expanding faster and faster. Galaxies that are not already bound together by gravity, for instance, galaxies outside our local group, will recede from us at ever-increasing speeds. Far, far into the future, tens of billions, then hundreds of billions of years from now, distant galaxies will be so far away and moving so fast that their light will no longer reach us. They will effectively disappear from view, sailing beyond the cosmic horizon caused by the accelerated expansion. An observer in that far future, perhaps living in a galaxy supercluster that has long since merged into one massive galaxy, might look out and see nothing but darkness beyond their own galactic neighborhood. The stars within that single cosmic island will age and die, with fewer new ones born as galaxies exhaust their gas. One by one, the lights will go out. Eventually, hundreds of billions or trillions of years from now, only the dimmest embers, white dwarf stars, and slowly evaporating black holes will remain against a backdrop of expanding void. This is the fate known as the Big Freeze or heat death of the universe, an ever-cold, ever-diluting expanse where activity winds down. It sounds like a bleak ending, but it's important to remember that this would unfold over an incomprehensibly long time scale, many orders of magnitude longer than the current age of the universe, which is about 13.8 billion years. We are talking about events in the extremely far future, practically eternity from our perspective. And the process would be gentle and gradual. No single moment would feel apocalyptic. Rather, it would be the slow dimming of lights, an increasing isolation stretching over eons. For any hypothetical beings living at that time, the gradual change would likely be imperceptible on human timescales. No dramatic collapse, just the universe quietly growing cold and empty. It would be the gentle winding down of cosmic activity, the slow, silent sunset of the cosmos. There is another theoretically possible fate, which was mentioned earlier: the Big Rip. If the nature of dark energy is such that it grows stronger over time, unlike a constant energy density, then eventually it could overcome all forms of binding, not just between galaxies, but within them as well. In that extreme scenario, first galaxy clusters would be pulled apart, then galaxies themselves would be torn as dark energy's repulsion overcame the gravity holding them together. Then star systems, and finally, in the very final moments, even atoms and subatomic particles might be ripped asunder when dark energy's push became infinitely strong. The universe would end in a violent explosion of every bound structure. However, current observations strongly suggest that dark energy behaves very much like a cosmological constant, remaining at a fixed density as the universe expands, not growing in that runaway fashion. So the Big Rip scenario appears unlikely given what we know now. It remains a fascinating speculation, but the evidence points toward the quieter, lonelier fate of eternal expansion, the Big Freeze, rather than a sudden disruptive end. The introduction of dark energy into our cosmological model has been supported by other lines of evidence as well. Measurements of the cosmic microwave background, the faint afterglow of the Big Bang, indicate that the geometry of the universe is very nearly flat, meaning, on large scales, the fabric of space-time isn't strongly curved overall. For the universe to be flat, the total amount of energy and matter in the cosmos must equal a certain critical density. The combined contributions of normal matter and dark matter fall short of that critical density by a large margin. Dark energy fills in the gap. Additionally, detailed maps of galaxy clustering and the way sound waves moved through the hot early universe, imprinted as subtle oscillations in the distribution of galaxies today, known as baryon acoustic oscillations, all point to the same conclusion: a universe dominated by dark energy. In fact, it is through observations like WMAP and Planck, satellite missions that measured the microwave background, that we arrived at the breakdown of roughly 5% normal matter, 27% dark matter, 68% dark energy that was mentioned earlier. So although we haven't detected dark energy in a laboratory, and perhaps we never will, since it seems to be a property of space itself, its fingerprints are all over the structure and evolution of the universe. The nature of dark energy remains one of the biggest open questions in physics. Is it truly a constant property of space, like an immutable feature of the vacuum? Or is it something dynamic, something that evolves over cosmic time? Some theorists have introduced the concept of quintessence, a hypothetical slowly changing field pervading space, whose energy density might vary. If quintessence exists, dark energy might not always have the same strength. It could have been different in the past and could change in the future, perhaps even eventually reversing or fading. So far, however, all observations are consistent with dark energy being a cosmological constant, unchanging, steady, like a metronome that keeps the same beat, driving acceleration at a constant rate. Others have speculated that what we call dark energy might hint at new physics in our theory of gravity. Einstein's general relativity has passed every test in our solar system and even on galactic scales with flying colours. But could it be that on the scale of the entire universe, gravity doesn't operate exactly as we expect? Some alternative theories of gravity, sometimes called modified gravity theories, have been proposed, where gravity's behaviour changes over very large distances or in very low density environments, potentially doing away with the need for dark energy by explaining accelerated expansion through a tweak of gravity itself. So far, none of these alternatives fit the full range of observations, as well as the simple idea of dark energy. But scientists keep them in mind, as they remind us not to take our current understanding as the final word. If nothing else, exploring such ideas stretches our minds to consider possibilities beyond the standard paradigm. Now, let's pause and take a gentle cosmic breath. We've travelled a long way in our minds. We started from the comfortable realm of Earth and the stars we see, then ventured into the concept of dark matter holding galaxies together and forming cosmic structures, and then pushed further into the idea of dark energy accelerating the expansion of the entire universe. These concepts can feel vast and almost overwhelming. Even professional scientists feel the profound implications, and sometimes even a bit of vertigo contemplating them. It's okay if some of the details swirl beyond easy understanding. We don't need to grasp every piece at once. We can simply float in the broad realization that our universe is more immense and mysterious than we perhaps ever imagined. Up to now, we have been speaking of dark matter and dark energy as things within our universe, as two key ingredients in the cosmic recipe that we're trying to decipher. Together, they make up about 95% of everything, leaving only a few percent as the normal matter we once thought was all there is. It's staggering to think that all the galaxies, stars, planets, and even the intergalactic gas, everything made of atoms, amount to just a cosmic icing on a vast, invisible cake. But having now surveyed these known unknowns, a playful curiosity arises. Could there be even more layers to reality that we haven't yet considered? We have explored the unseen parts of our own universe. What about the possibility of entire other universes or dimensions beyond our direct perception? In other words, could the dark side of the universe include not just unseen components in our own space and time, but perhaps realms or aspects of existence that lie outside what we can observe? This leads us into a more speculative, but wonderfully imaginative part of our journey. We have our firm observational mysteries, dark matter and dark energy, grounded in evidence. Now we allow ourselves to wander toward the fringes of science, where it blends softly into philosophy and wild theory. Here we tread gently, not with the sure foot of empirical data, but with the soft slipper of speculation. Our goal isn't to assert these upcoming ideas as true, but to explore them as possibilities, to stretch our imaginations on the vast canvas of the unknown, while keeping our tone calm and our minds open. One idea that arises in this speculative realm is the notion of a shadow universe, or mirror world, existing alongside our own, containing matter, and even perhaps galaxies and stars, but in forms that barely interact with anything in our universe. In this scenario, what we call dark matter might actually be matter from this parallel world gravitationally affecting ours. Imagine for a moment that every particle we know, electrons, protons, and so on, has a counterpart, a mirror particle, in a hidden sector of reality. This mirror matter would have its own mirror electrons, mirror atoms, and maybe even whole mirror galaxies. We would not see the light from those galaxies because mirror photons, the particles of light in the mirror world, wouldn't interact with our eyes or our instruments. To us, those galaxies would be invisible. However, their mass would still exert gravity. It's almost like two overlapping worlds that don't directly touch, except through the whisper of gravity. If you and I are made of ordinary atoms, a mirror being made of mirror atoms could be standing right here, and neither of us would know. It would be as though we're ghosts to each other, coexisting in the same space, but interacting only via a faint gravitational influence. This concept of mirror matter comes from speculation about fundamental symmetries in physics. In our known physics, the laws distinguish left-handed from right-handed in certain interactions, something that puzzled scientists in the mid-20th century. Some wondered if perhaps nature restores balance by having a duplicate set of particles that are like a mirror reflection of the ones we know. A whole parallel sector where left and right are swapped, so that overall symmetry is preserved. It's a bit of an abstract idea, but it results in the notion of a hidden twin universe. While there's no definitive evidence that such a mirror world exists, scientists have actually pondered how we might detect a hint of it. For instance, could there be a particle occasionally transitioning between our world and the mirror world? Experiments have been designed to see if, say, neutrons might sometimes disappear into a mirror state for a brief time before coming back, because a neutron that turned into its mirror twin would vanish from our detectors during that interval. So far, no conclusive sign of such transitions has been found, but the very fact that such experiments are being done highlights how seriously even far-out ideas are considered when trying to solve cosmic mysteries. One can even whimsically wonder, could there be mirror stars with mirror planets, maybe even mirror life evolving in that parallel cosmos? If so, neither world would ever directly perceive the other. Each would be essentially a ghost to the other's reality. This idea moves towards science fiction, of course, but it underscores how mysterious and rich the cosmos might be. That even sharing the same physical space, two entire universes could coexist without awareness, like overlapping shadows. Whether or not a true mirror universe exists, it's one imaginative way to picture dark matter, not just as some new particle in our universe, but possibly as matter from a whole other realm that only whispers to ours via gravity. Another frontier of speculation touches on the idea of higher dimensions. We are accustomed to 3 dimensions of space, length, width, height, and one of time. But some theories in physics, particularly string theory, suggest there could be additional spatial dimensions beyond the 3 we experience, dimensions that might be hidden, either by being very small or because we're confined to a 3-dimensional surface within a higher dimensional space. This leads to the notion of brane worlds from membrane, where our universe could be like a 3-dimensional sheet floating in a larger, higher dimensional space, sometimes called the bulk. Think of our universe as a flat sheet of paper, which, in this analogy, has 2 dimensions, drifting in a 3-dimensional room. Now imagine another sheet of paper, parallel to ours, somewhere in that room. The inhabitants of each sheet, if there were any, would live their lives in their own 2-dimensional surface and have no awareness of the other sheet because they cannot see or move through the 3rd dimension that separates them. However, if you placed a heavy ball on one sheet, its gravity, which extends through the room, could be felt on the other sheet as a mysterious influence, even though the creatures on that second sheet can't see the ball itself. In a similar way, Our three-dimensional universe could be like a sheet, a 3D brain, in a higher dimensional space. There could be other brains, other three-dimensional universes, parallel to ours in that higher dimensional space. Normally, each universe would be self-contained. We on our brain wouldn't see or touch anything on another brain. But gravity might be a special case. Since gravity is associated with the curvature of space-time itself, it could potentially leak between brains. If a large amount of matter resided on another brain, not far from ours, in the higher dimensional sense, its gravity might trickle into our brain. To us, it would seem like the gravity from an unseen source, mass with no light. Some scientists have proposed exactly this, that maybe dark matter is ordinary matter located in a hidden, higher dimensional realm whose gravity spills into our universe. To the inhabitants of that other brain, we would be the invisible ones, our matter perhaps contributing to their dark matter. These higher dimensional theories are hard to test, but they offer a beautiful conceptual possibility. They remind us of how limited our perception might be. Just as a flatlander, a hypothetical being living on a 2D sheet, would find it hard to imagine a third dimension, we find it difficult to picture a fourth or more spatial dimension. Yet mathematics and physics don't forbid them, and in those extra dimensions could lurk answers to puzzles like dark matter, or even dark energy, some have suggested. For now, if such extra dimensions exist, they remain hidden, like secret rooms adjacent to our world for which we have yet to find the door. In any case, pondering higher dimensions expands our mind to the vast potential layers of reality. Speaking of realms beyond our own, let's consider the idea of the multiverse. Traditionally, the word universe means everything that exists. But modern cosmological theories, especially those related to cosmic inflation, the very rapid expansion thought to have occurred just after the Big Bang, suggest that our universe might be just one bubble in a frothy sea of universes. According to some inflation models, while our region of space underwent inflation and then stopped to form particles and galaxies, other regions of space might still be inflating, or might have inflated separately, giving rise to other bubble universes disconnected from ours. If this picture is true, it's speculative but grounded in some interpretations of inflation theory, then reality would be far larger than what we can observe. There would be countless other universes, each with perhaps different properties, maybe different amounts of dark matter, or even different physical constants, like different strengths of forces or different types of particles. If the multiverse idea is true, these other universes are likely forever inaccessible to us, as they would be separated by vast inflating regions, or essentially be in disconnected space-times. We cannot travel to them or see them. They lie outside our observable horizon and perhaps outside any causal contact with us. However, one might wonder if occasionally there could have been some subtle contact. Perhaps if another universe bubble collided with ours in the very distant past, there might be a faint imprint in the cosmic microwave background, like a circular pattern or bruise. Some cosmologists have indeed searched the microwave background sky for such circular anomalies that might hint at a collision with another universe. So far, none have been convincingly found, but the very act of searching is fascinating. It shows we are trying to find empirical footholds even for these grand ideas. Similarly, there was an observation once dubbed dark flow, where certain galaxy clusters appeared to share a coherent motion in one direction, as if being pulled by something beyond the visible universe. This led to speculation that perhaps the gravity of a massive structure outside our observable region was tugging on them, a kind of cross-universe influence. Later studies cast doubt on the dark flow's significance. It's debated whether that motion is real or just an artifact. but it's an example of how we are alert to any hints that might point to a reality larger than the one we see. The multiverse, if it exists, would mean that reality is even broader and more diverse than we have yet imagined. Some universes in the multiverse might be almost empty or filled mostly with dark energy causing runaway expansion. Others might have collapsed long ago. Some might have a completely different balance of forces where no stars can form. Others might be teeming with stars and maybe life. It often leads to a philosophical point called the anthropic principle. We find ourselves in a universe that is suitable for life, with the right constants and ingredients. Because only in such universes could observers like us arise to ask the question. If there are countless universes, it's not surprising that at least one has the right conditions for galaxies, stars, planets, and people, namely ours. But beyond that line of thought, contemplating the multiverse can be both mind-boggling and strangely calming. On one hand, it suggests infinities upon infinities of possibilities, worlds without end, truly a boundless ensemble in which anything that can happen might happen somewhere. On the other hand, it can make our own cosmic stage, the one we've been discussing with its dark matter and dark energy, feel even more special, like one habitable oasis in a vast archipelago. Or it might make us feel even more humble, realizing that even our vast universe might be just a drop in an immeasurable ocean of universes. We have to acknowledge that these ideas, mirror worlds, extra dimensions, multiple universes, are speculative. They don't, yet, have the solid backing of evidence that dark matter and dark energy do, through their gravitational effects and observations. But they represent the human mind stretching to find contexts in which to place these mysteries we have discovered. They may not have proof behind them yet, but exploring such possibilities inspires our imagination and keeps alive the sense of wonder that propels science forward. We are like explorers who have mapped a vast new continent, the dark matter and dark energy dominating the cosmos, and then begin to wonder what oceans or further lands might lie beyond the edges of the map we've drawn. Now, as our journey through these shadowy possibilities comes to a restful pause, let's reflect on where we have been. We started with the tangible mystery of dark matter, uncovered by observing the motions of galaxies and clusters, a discovery that taught us humility about the limits of sight. We then turned to an even grander enigma: dark energy, the gentle but relentless push causing the expansion of the universe to accelerate, a phenomenon discovered by watching distant stellar explosions flicker at the edge of the observable cosmos. From there, we allowed ourselves to wonder about even more hidden things, perhaps entire mirror worlds overlapping ours, or extra dimensions and parallel brains, or a multiverse of countless bubble universes beyond our horizon. These ideas live at the fringes of science, where hard evidence is scant, but they serve to remind us just how much mystery remains. Think about what all this means for our sense of existence. A little more than 100 years ago, we didn't even know for sure that other galaxies existed beyond the Milky Way. Within the last century, we discovered that the universe is expanding. Then we found that most of the matter in galaxies is invisible dark matter. And finally, we learned that an unexplained dark energy is pushing the galaxies apart, faster and faster. Each time we uncovered a new layer of reality, our cosmic perspective grew larger and more mysterious. We humans find ourselves living in a universe that is mostly invisible. It's a humbling realization, yet also a poetic one. It means there will always be secrets to uncover and new wonders to inspire us. The darkness that surrounds us is not empty. It's a canvas on which our curiosity can draw new questions and seek their answers. By residing in a cosmos where so much is unseen, we learn to cherish the light we do have and to find meaning in the very act of exploration and discovery. At this point, you might feel a mix of awe and perhaps a gentle vertigo from contemplating such immensity and deep mystery. That's a natural feeling, one shared by many astronomers and thinkers who grapple with these questions. But remember, the goal of our journey has not been to leave us in confusion or fear, but rather to instill a calm sense of wonder. It shows us that no matter how much we learn, there will always be more to discover. And that is a beautiful thing. The unknown is not a darkness to be feared, but a frontier that invites us to explore at our own pace, with wonder and humility. We don't need all the answers tonight. It is enough to marvel at the questions and appreciate the incredible tapestry of the known and unknown that we are part of. Now, let's gently return to a more immediate sense of here and now, carrying with us the insights and tranquility gained from our voyage through cosmic darkness. Perhaps now, to truly appreciate the grand scale of these discoveries, we can take a little imaginative journey through space and time to see them in context. Picture yourself once more under a clear night sky on Earth. You are standing on a quiet hill far from city lights. The Milky Way arcs overhead as a misty band of light. Thousands of stars are visible, clustered thickly in that band, which is the plane of our galaxy seen from within. It's a breathtaking sight, the kind that has inspired wonder since the dawn of humanity. For a moment, feel the cool night air and the gentle stillness around you. Now imagine gently lifting off the ground, as if you have shed the weight of your body. You rise through the atmosphere, leaving the sounds of Earth behind, until you find yourself floating in space, above our beautiful blue planet. The Earth shrinks below you, a glowing orb of blue oceans and white clouds. The moon, silent and grey, comes into view, and as you continue outward, the sun's brilliant light bathes you. Soon, you've left the solar system entirely. The sun is now just one bright star among many. You pass by other stars, some solitary, some with their own planets. The constellations shift as your perspective changes. Orion's familiar pattern distorts and then becomes unrecognizable. You are moving at impossible speed, yet in this imaginary journey, it feels smooth and effortless. As you continue outward, the disk of the Milky Way takes shape. You begin to see it from the side, then from above. Our galaxy spreads out below you like a vast, glowing spiral with graceful arms. It's like a giant pinwheel made of stars, with a bright core and thinner spiral arms swirling around it. Here and there you see glowing nebulae and clusters decorating the arms. But now we add the unseen. Enveloping this glittering spiral, imagine an enormous, faintly luminous halo indicating the dark matter. The galaxy is embedded in an invisible ball that far exceeds the visible edge. In this mental image, perhaps we colour the dark matter halo in a gentle blue glow just for visualization. The Milky Way, in that view, is a small jewel at the centre of a much larger hazy sphere. We journey further out. The Milky Way becomes just one galaxy among many. You see its neighbour, the Andromeda Galaxy, a spiral larger than our own, looming nearby. Andromeda and the Milky Way are on a slow collision course, destined to merge billions of years from now. Together with dozens of smaller satellite galaxies, including the Magellanic Clouds and others, they form the local group of galaxies. In this region, gravity, largely provided by dark matter halos of the group, binds these galaxies together, so they do not recede from each other despite the universe's expansion. You watch as Andromeda and the Milky Way move gently toward one another, drawn inexorably by their mutual gravitational tug. Drifting further outward, the local group begins to recede into the distance, and more galaxies become visible. We approach the Virgo cluster, a massive cluster of galaxies not far, in cosmic terms, from our local group. Hundreds of galaxies reside here, bound in a huge cluster about 50 million light-years away from us. From our vantage, it looks like a glittering swarm of lights. Some are giant ellipticals, huge balls of stars. Others are spirals. Many are smaller dwarfs. This cluster, too, is permeated by dark matter, far outweighing the visible galaxies. Its gravity is strong. Small groups like our local group are being pulled toward it even now. Perhaps you notice subtle arcs of light, the effects of gravitational lensing, as the cluster's mass bends the light from even more distant galaxies behind it. Leaving the Virgo cluster behind, we travel even faster now, accelerating outwards. Galaxies start to blur into a cosmic web. Filaments of galaxies stretch across space, connecting cluster to cluster. We pass by countless galaxies, some similar to our Milky Way, some vastly different. We cross great voids with barely a galaxy in them, just a faint haze of intergalactic gas and dark matter drifting. We witness cluster collisions, like the bullet cluster in the distance, seeing those telltale offsets of pink gas and blue dark matter in our mind's eye color scheme. We are seeing the large-scale structure, an immense cosmic web with patterns hundreds of millions of light-years across. Our journey isn't done. We accelerate even more, moving beyond the scale where individual galaxies can be discerned. The web of galaxies fades into a mist of tiny dots. Eventually, even that dissipates into darkness. We are now approaching the very edge of what is observable. The galaxies have redshifted into faint smears of light due to their rapid recession. Finally, we reach a sort of wall of light, the cosmic microwave background surface. It appears as a faint, almost uniform glow in all directions. In our imaginary journey, we might translate it to visible light for a moment. We see a dull, orangish glow surrounding us like the inside of a sphere. This light comes from about 380,000 years after the Big Bang, when the hot plasma of the early universe cooled enough to become transparent. It is the oldest light we can see, marking a horizon beyond which the universe was opaque. At this extreme vantage point, we also become aware of dark energy's role. We sense that space itself has been expanding all along, faster and faster. The galaxies that once were in view are now mostly beyond the horizon. The acceleration caused by dark energy means that as time goes on, less and less of the universe will be observable from any given point. It's as if we stand at an ocean shore in twilight, watching the lights of ships, galaxies, drift away until they vanish over the horizon, one by one. Now gently, let's imagine returning home. We have travelled outward through our cosmic neighbourhood, to clusters and superclusters, all the way to the limits of the observable universe. We have seen, in our mind's journey, the grandeur of the cosmic web, shaped by dark matter, and felt the vast scale of the expansion driven by dark energy. Now we retrace our steps. We watch the microwave background fade away behind us as we move closer again. Galaxies reappear, blue shifted now as we outrun the expansion on our return journey. We find ourselves back at the Virgo cluster, then the local supercluster Laniakea, which contains Virgo and our local group, then back at our local group itself. The Andromeda Galaxy and the Milky Way welcome us like familiar landmarks. We close in on the Milky Way, seeing its spiral arms once more, and slip back into our position in the Orion arm of the galaxy. Ahead, our sun glows warmly. We pass the outer planets, Neptune with its deep blue hue, then the rings of Saturn, the giant Jupiter, and finally the inner planets, until Earth comes into view again, shining with the reflected light of the sun. We descend gently through the atmosphere, clouds parting below as we settle back down to the quiet hill under the stars, where we began. Standing on that hill under the stars again, we have a newfound appreciation for the darkness of the night sky. The Milky Way still arches overhead, serene and silver. But now we understand that the darkness between those stars is not empty. It's full of the gravity of dark matter and the expansive breath of dark energy, a silent orchestration shaping everything we saw. Perhaps you feel a sense of comfort standing there, knowing that even the unseen parts of the universe are holding you in their gentle embrace. The dark side of the universe, which once might have seemed foreboding, now feels like a quiet, profound backdrop that enriches the beauty of the stars. From the darkness, we have wrested light. Our sun gives us day. Our curiosity gives us understanding. Though most of the cosmos is hidden from our eyes, we have used our minds and instruments to unveil a surprising amount of it. Like explorers mapping a nighttime landscape by lantern, we have illuminated some corners and found outlines of vast mountains and valleys in the dark. We know dark matter is there, even if we cannot see it directly. We know dark energy is at work, even if we cannot feel it in our daily lives. Bit by bit, we have expanded the circle of light into the darkness of the unknown. There is a poetic comfort in knowing that the darkness is not emptiness, but rather full of influence and substance. When you gaze up on a clear night, most of what you see is blackness studded with stars. Once, we might have thought that blackness was simply void. Now we know that in that void there is structure and energy. The majority of existence, in fact. The night sky might appear tranquil and empty, but it is humming with the unseen. The gravitational pull of dark matter binding galaxies, and the gentle pressure of dark energy stretching space. It is as if the universe has two faces. One, the bright face of stars and galaxies that greet our eyes. The other, a hidden face, dark, subtle, yet powerful, forming the foundation and determining the fate of all we see. As our journey in this part of the documentary draws to a close, feel free to let these thoughts drift through your mind at their own unhurried pace. You don't need to hold on to every detail. It's perfectly fine if some concepts remain fuzzy or mysterious. After all, they are meant to be. The aim was never to solve all the darkness, but to gently explore it, to become comfortable with its vast presence, and maybe to find a certain peace in knowing that so much of the universe lies beyond the visible. It shows that there will always be more to learn, and there is a quiet joy in that realization. Think of yourself once more, floating in that starless void, with which we began. But now you know that void is not truly empty. You sense the weight of dark matter halos around galaxies, their gravitational presence subtly brushing past you. You sense the stretch of dark energy inexorably widening the space between galaxy clusters. You might even imagine, with a whimsical smile, that alongside you perhaps lies a shadow world, just out of reach, or other universes flickering beyond the cosmic horizon. All is dark around you, but it is a fertile, creative darkness, full of possibilities and gentle wonders. Let yourself feel the comfort of that darkness. Just as night on Earth is a time of rest and renewal, the cosmic darkness holds and nurtures the seeds of galaxies and stars, and cradles the universe in its invisible arms. The dark side of the universe is not a thing to fear. It is a quiet, profound backdrop to all that is visible. In knowing of its existence, we become a little more connected to the cosmos, as if acknowledging an old friend who has always been there, unseen but not absent. Our voyage through the dark side of the universe continues, drifting gently from the wonders of unseen matter and phantom energy into another profound mystery. We have journeyed past the veil of dark matter and the expansive push of dark energy. We have imagined mirror worlds and higher dimensions, and dared to step among a multiverse of possibilities. The stars around us are like distant island lanterns on this cosmic sea, and the space between them is the deep, dark water. We gently sail onward, carried not by wind, but by curiosity and imagination. Ahead, where the starlight thins out, we sense the presence of something profound and unseen. Now, as we float in the quiet cosmic ocean, we find ourselves drawn toward a different kind of darkness. A darkness not of endless expanse, but of infinite depth. In the distance, a silent abyss awaits. A black hole, perhaps the most enigmatic of all cosmic phenomena. We approach this cosmic abyss slowly, allowing wonder to overtake fear. Black holes are regions of space where gravity has become overwhelming. In most cases, they are born from the death of a massive star that has run out of the fuel that made it shine. When a star, much larger than our sun, reaches the end of its life, it can no longer hold itself up against its own gravity. In a dramatic instant, the core of the star collapses inward. The outer layers may erupt outward in a colossal supernova explosion, a brilliant, fleeting blaze visible across galaxies. But deep at the center, the core continues to implode, compressing tighter and tighter. If the star was heavy enough, nothing can stop this collapse. Atoms themselves are crushed, and the core shrinks beyond imagination, forming a black hole. What remains is an invisible remnant of the star, a region of intense gravity left behind in the aftermath of that final stellar death throe. The mass of many suns may be crushed into a point no larger than a pebble, wrapping space and time around it like a shroud. The result is a gravitational trap so deep that nothing, not even light itself, can climb back out. It is as if a hole has been punched in the fabric of reality, an opening into pure darkness. This might conjure an image of a cosmic vacuum pulling in everything around it. But in truth, a black hole follows the same gravitational laws as any other object with mass. Only when you venture very close to it does its special nature become overwhelming. If, for example, our Sun could magically collapse into a black hole of the same mass, the Earth and planets would continue to orbit in almost the same way as before. Our world wouldn't get pulled in from 93 million miles away, though we would be left without sunlight. The black hole's sun would tug on us gravitationally, just as the real sun did. It's only in the immediate neighborhood of the collapsed star, within a few miles of that dense center, that gravity's pull becomes irresistible and inescapable. Stay farther out, and you could theoretically orbit a black hole safely, just as a satellite orbits Earth, or Earth orbits the Sun. Yet this darkness is not malevolent or evil. It simply is, a consequence of nature's laws taken to an extreme. In our mind's eye, we drift safely at a distance, observing the black hole against the starry background. From far away, it might not look like much at all. We cannot see the black hole itself, since no light reflects from its depths. Instead, we notice a curious absence of stars in a circular patch of sky, as though a piece of the night has been cut out with invisible scissors. At the edge of that patch lies the event horizon, the boundary beyond which nothing returns. It's a point of no return, a silent border in space. To us, it appears as an almost ghostly silhouette, defined more by what is around it than by any feature of its own. If a glowing disk of gas spirals into the black hole, we might see the material light up as it swirls faster and heats, a final brief cry of light before crossing the horizon. But once it passes that edge, it vanishes from our universe's view, as though it were never there. There is a subtle beauty in this cosmic silhouette. Sometimes, light from distant stars skims close to the black hole and is bent around it, like a river flowing around a rock. This gravitational lensing can create a delicate halo or ring of light encircling the darkness. To our eyes, it might appear as a faint, distorted glow outlining where the black hole lies, an almost artistic flourish by the laws of physics. In this way, even the darkest of cosmic objects can wear a crown of bent starlight. In fact, humanity has even glimpsed such a halo directly. With powerful telescopes working in unison, scientists captured the first portrait of a black hole's shadow. In that image, a gentle ring of light traced the outline of darkness, a sight once only imagined, now made real. That particular black hole lies in a galaxy millions of light years away. Closer to home, at the center of our own Milky Way, another supermassive black hole resides. We cannot see it with our eyes, but we know it is there. We have watched a cluster of stars whipping around an apparently empty spot, moving so fast that only a huge concentration of mass could cause it. That mass, equivalent to about 4 million suns, is crammed into a space smaller than our solar system. It's our galaxy's central dark heart, usually quiet, occasionally flaring as it snacks on stray gas. One day, perhaps, we might image that black hole's silhouette as well, peering into the darkness at the core of our home galaxy. Black holes themselves come in different sizes. Some are born when massive stars reach the end of their life and collapse. These black holes might weigh a few times the mass of our Sun and have horizons only a few miles across. Others are incomprehensibly larger, supermassive black holes residing in the hearts of galaxies, containing millions or even billions of suns worth of mass in a single dark point. The event horizon of a supermassive black hole can span a region larger than our entire solar system. Despite their darkness, these cosmic giants can become the engines for astonishing displays of light. If gas and dust funnel into a supermassive black hole, they form a spinning disk around it, heated to such extreme temperatures that it glows brilliantly. Sometimes, twin jets of energy shoot out from above and below the disk, creating cosmic beacons that can be seen across the universe. Quasars, some of the brightest objects ever observed, are powered by feeding supermassive black holes, shining as if 100 galaxies were condensed into a single point of light. It's a breathtaking contrast. The very darkness that lets nothing escape is surrounded by a furious halo of light and energy at its threshold. Now, in our thoughts, let's send a fearless explorer toward this cosmic abyss. If they were to drift close to the event horizon of a sufficiently large black hole, something remarkable happens. They might not even notice the exact moment they slip across that fateful border. There would be no sudden bump, no violent jolt. Crossing the horizon of a supermassive black hole could feel eerily normal. In fact, it might even feel strangely peaceful. A gentle drifting beyond the point of no return. The traveller would simply continue floating in space, yet now irreversibly inside the black hole's grasp. From the outside, however, things appear very different. An observer watching our explorer fall toward the black hole would see their movement slow down as they approach the horizon. The closer the explorer gets, the slower time seems to flow for them, at least from the distant observer's perspective. Their clocks would tick ever more slowly. If the explorer had a light on their ship, that light would gradually shift to redder and dimmer hues, its energy drained by the intense gravity. To the outside universe, our intrepid traveller would never quite appear to cross the threshold. They would seem to hover at the edge of the event horizon, growing fainter and more red, time almost frozen, until eventually their image fades away into darkness. For the explorer themselves, though, time would feel ordinary. They would fall straight inward, unaware of how strange their journey looks to outsiders. If they glance back, they might see the outside universe above them, distorted into a shrinking circle of light. It would be like diving deep into the ocean and watching the bright surface recede to a small, glowing patch overhead. All around, in every other direction, blackness as the walls of space-time curve inward. All around is silent. There is no air, no sound, only the steady pull downward. The explorer might feel weightless, suspended in a slow freefall. There's no sense of wind or motion, just the gentle tug of gravity guiding them inward. It could almost feel like dreaming, drifting deeper and deeper into a long night. Our traveller would continue forward into the unknown, carried by gravity to whatever fate awaits at the centre. What lies at the very heart of a black hole is beyond our current understanding. The known laws of physics begin to break down under the extreme conditions of the core, a point called the singularity. All the mass that fell in might be crushed to an infinitely dense dot, or perhaps something stranger happens that we cannot yet fathom. One thing is certain. Once something has passed the event horizon, it is effectively cut off from the rest of the universe. It vanishes from our observable realm, carrying its secrets inside. This raises a profound question. Does information about those objects simply cease to exist? If a black hole swallows a star, erasing all trace of its light and matter from the outside world, is the star's story gone from the universe forever? This conundrum is known as the black hole information paradox, and it remains one of the great unsolved mysteries of physics. According to quantum theory, information about matter and energy can never be truly destroyed, only transformed. But if a black hole simply locks away everything that falls in, it would seem to erase information from the universe. A hint at a possible answer comes from a surprising source. Black holes, it turns out, might not be entirely black. In the 1970s, physicist Stephen Hawking proposed that black holes can slowly emit a very faint glow of particles, a phenomenon now known as Hawking radiation. This happens because of quantum effects, right at the event horizon. Pairs of virtual particles flicker into existence from the energy of the vacuum itself. Normally, these particles annihilate each other almost immediately. But at the edge of a black hole, one particle from such a pair might fall in while the other escapes. The escaping particle carries away a tiny bit of the black hole's energy. To a distant observer, the black hole appears to radiate particles and lose mass over an extremely long span of time. Over unimaginable eons, this trickle of radiation would cause a black hole to slowly evaporate, shrinking bit by bit. A black hole that isn't fed new material will eventually disappear completely, dissolving into faint particles and energy spread out into space. But this leads to a deep puzzle. When the black hole is gone, what has happened to everything it consumed? If the information about those swallowed objects is truly lost, it would violate a fundamental rule of quantum physics. Many scientists now suspect that the information isn't really destroyed at all. Instead, perhaps it is encoded in some subtle way in the Hawking radiation that the black hole emits, so that by the end of its life, the information has leaked back out into the universe, albeit in a highly scrambled, unrecognizable form. One way to think about it is to imagine throwing a book into a fire. The pages burn, and the words are seemingly lost. But if you could somehow collect all the smoke and ashes and the heat released, in principle, the information from the book isn't destroyed. It's just transformed into a very difficult to read form. Likewise, when a black hole eventually radiates away what it has absorbed, it might be returning the pages of information, but torn up and scrambled into heat and particles. The story that fell in would be beyond recognition, yet perhaps not fundamentally erased. Some theories suggest that the information might be stored at the black hole's event horizon itself, woven into the quantum fabric there, like a kind of hologram. In this view, the event horizon could hold an encoded record of everything that falls inside, preserving the information even as the interior remains mysterious. Then, as Hawking radiation slowly carries energy away, it could also carry away those encoded details bit by bit. The truth is, we still don't fully understand the answer. Black holes keep their secrets well. This paradox has led scientists on a journey to reconcile gravity and quantum physics, two frameworks of nature that usually don't fit neatly together. The resolution of the information puzzle may unlock new understanding of space, time, and the fundamental way the universe works. For now, as we drift in thought near our silent black hole, we can appreciate that even in its silence it whispers hints of new physics to us through puzzles like these. the mysteries of black holes naturally stir our imagination. We might ask, are they truly the ultimate dead end for anything that falls inside? Or could they be doorways of a sort? When faced with a seemingly absolute boundary, like the event horizon, the mind drifts to possibilities that transcend our normal experience. For generations, storytellers and scientists alike have imagined that maybe, just maybe, falling into a black hole isn't the end of the story. Perhaps there could be another side, a way through the darkness. This line of thought leads us into the realm of wormholes, those hypothetical tunnels through space-time that offer a kind of escape hatch from a black hole's finality. Relativity's equations even allow for a bizarre hypothetical object known as a white hole. A white hole can be thought of as the opposite of a black hole. Instead of pulling everything in, it pushes everything away. Nothing can enter a white hole past its event horizon from the outside, but matter and light can emerge from it. In a sense, it's like a time-reversed black hole, where a black hole swallows, a white hole spews. No white hole has ever been observed, and if they exist at all, they might only arise under extraordinary conditions or as part of a wormhole connection. Some have even speculated that the Big Bang itself, which burst forth all matter and energy, could be akin to a one-time, gigantic white hole. It's a fanciful idea, highlighting just how strange and wonderful the cosmos may be, with possibilities that sound like magic. By that thinking, perhaps every black hole could be like a cosmic seed, an embryo of a new universe invisible to us. What vanishes into a black hole in our world might give birth to galaxies and stars in another reality entirely, carried there through the one-way door of a white hole. In such a picture, the death throes of a massive star in one universe, its collapse into a black hole, would be akin to a creative act in another universe, a kind of cosmic recycling on the grandest scale. Our own universe's Big Bang could even have been the other side of a black hole that exists in a larger reality. These ideas remain speculative, but they beautifully illustrate how connected everything might be, and how what seems like an end in one realm could be a beginning in another. Even so, wormholes remain entirely hypothetical. Einstein and physicist Nathan Rosen found that the math allowed for what appeared to be tunnels through space-time, now often called Einstein-Rosen bridges. In principle, a wormhole could connect two black holes or a black hole and another distant region of the cosmos, providing a path from one to the other. However, these mathematical wormholes seem to snap shut so quickly that not even a single photon of light could traverse them. To hold a wormhole open, theorists speculate that exotic forms of matter with negative energy might be needed. Something that has been hypothesized, but never observed in practice. None of this has ever been detected in the cosmos. If wormholes do exist naturally, they might appear and disappear on the tiniest scales, or hide in the far reaches of the universe beyond our current observation. And yet, it's soothing to entertain the idea that somewhere out there, a gentle tunnel of stars and light might connect distant corners of space. Imagine for a moment that such a passage could be found or created. What would it feel like to journey through a wormhole? Perhaps it would be like stepping into a shimmering doorway hung in space. As you cross the threshold, the universe around you might twist into a kaleidoscope of warped light. You might feel no motion at all, but the stars and galaxies could stretch and blur around you, as if you were moving through a tunnel of glowing mist. Then, in the blink of an eye, you'd emerge in a completely different region of space, maybe millions of light years from where you began. The sky around you would be unfamiliar, new constellations glittering softly. Perhaps you would find yourself near the glowing clouds of a nebula in a distant galaxy, watching newborn stars paint the darkness with ethereal color. Or maybe a giant spiral galaxy would stretch across the heavens like a pale, whirled disk of light, a view unlike any in our sky. It could even be a different time, perhaps far in the future or the distant past, depending on how the wormhole connects. The notion of using a wormhole as a cosmic shortcut also comes with the tantalizing idea of time travel. Relativity tells us that space and time are interwoven, so a bridge through space could also become a bridge through time. If one mouth of a wormhole were situated in a region where time flows differently, say near a black hole or moving at nearly light speed, then the two ends of the wormhole might not line up in time. In theory, one could enter a wormhole and exit not only somewhere else in the universe, but also at an earlier or later era. This raises all those famous paradoxes of cause and effect. What if someone could go back in time and alter the past? Would nature somehow prevent such loops in time from ever becoming reality? It seems the universe guards its sequence of events with great care, because so far we see no evidence of any time-traveling visitors or mischievous alterations of history. Interestingly, traveling into the future is not only possible in theory, it has been measured on a small scale. Time slows down for objects in motion or in stronger gravity, a truth confirmed by precise clocks on high-speed spacecraft and satellites. An astronaut who spends months on the International Space Station, for example, will return to Earth ever so slightly younger than if they had stayed at home, because time ran a touch slower for them in orbit. If one could travel at speeds close to the speed of light, or live near a black hole's intense gravity for a while, this effect would be far more pronounced. A year might pass for the traveller, while many more years pass elsewhere. In that sense, they would leap into the future. In our nightly dreams, we sometimes experience a similar curious phenomenon in a psychological sense, living through long episodes in what turns out to be only a short period of sleep. Time, it seems, can stretch or compress depending on your frame of reference. These puzzles draw our attention to a fundamental truth. In our experience, time has a direction. We sense an arrow of time that points from the past to the future. We remember what has already happened and anticipate what is yet to come, but never the reverse. A teacup shatters on the floor and the pieces scatter, but we never see the shards jump back into a pristine cup. Once cream disperses in coffee, it won't unmix itself back into separate milk and coffee. The ripples on a pond spread outward when a pebble is dropped in, and they never gather themselves back together to eject the pebble. All these everyday occurrences share a common theme: a tendency to move from order to disorder, from organized states to more disorganized states. This is the essence of the arrow of time. In scientific terms, this one-way progression is often explained by something called entropy, a measure of disorder or randomness. The entropy of a system tends to increase with time, meaning things naturally progress from organized configurations to more chaotic ones. It's why broken eggs don't spontaneously reassemble, and why we grow older and not younger. The arrow of time is essentially the arrow of increasing entropy. Even living beings like us follow this principle. We create temporary order within our bodies and lives, but only by expending energy and producing entropy in our surroundings. We eat food or absorb sunlight, maintaining our body's organization for a while. But ultimately we age, and our energy returns to the environment. In the big picture, life does not defy the second law of thermodynamics. It makes use of it, riding the flow of energy from order to disorder to build patterns temporarily. What's fascinating is that the fundamental laws of physics, at least for particles and forces, usually don't insist on a preferred direction for time. If you could watch molecules bounce around in reverse, the equations that describe them would still make sense. Yet on larger scales, with trillions upon trillions of particles, the chance of all random motions exactly reversing to rebuild a shattered cup is so unimaginably small that it never happens in practice. The universe, it seems, began in an improbably ordered state, and ever since, the entropy has been rising, giving time its forward march. And yet, one might wonder if time's arrow is a local story rather than a universal truth. Some scientists have speculated that the Big Bang might have given rise to more than one region of space-time, perhaps even a mirror universe in which time flows opposite to the way it does here. In that hypothetical mirror cosmos, what we call the future would be their past, and vice versa. To those hypothetical beings, if they existed, their entropy would always increase in what we think of as the backward direction. It sounds like science fiction, but it's an attempt to grapple with the question of why time has a direction at all. Perhaps the arrow of time in our universe is just one facet of a larger reality. In any case, in our everyday experience and throughout the observable cosmos we know, entropy increases and time moves forward, carrying us from yesterday to tomorrow. This arrow of time doesn't just govern teacups and coffee. It shapes the destiny of stars, galaxies, and the entire cosmos. Over the eons, stars exhaust their fuel and die, turning into white dwarfs, neutron stars, or black holes. Galaxies collide and merge, or gradually lose their gas and grow quiet. The universe expands, and as it does, matter becomes more spread out and diluted. Already we can see the early hints of this gradual quieting in the vast cosmic structures around us. Galaxies are not evenly distributed, but gather in clusters and long filaments, with tremendous voids in between. Zooming out, this arrangement looks like a web or a sponge, what astronomers often call the cosmic web. In this web, galaxies and clusters lie along filaments and walls, and the voids are like huge dark bubbles with almost nothing inside. It's a breathtaking pattern, matter tracing out the faint scaffolding of the universe, outlining the enormous spaces where hardly any galaxies shine. One such region, known as the Boötes void, is so large and empty that it defies imagination. It's a dark expanse where only a few galaxies inhabit a volume of space that would normally hold hundreds. If we could find ourselves drifting in the center of such a void, the view would be profoundly dark. Far off in the distance, perhaps a faint smudge of a galaxy cluster could be seen. But to the naked eye, it might just appear as a tiny pinprick of light, if anything at all. All around, in every direction, would be blackness, dotted with maybe a rare, lonely star. The usual majestic band of the Milky Way that we see from Earth's night sky would be absent. Instead, there'd be the pure night of intergalactic space, cold, silent, and still. It would feel as if you were utterly alone in the universe, suspended in a tranquil, endless night. In that solitude, there is a strange peace. Without any nearby suns or galaxies, the darkness is pure and undisturbed. The vacuum around you contains almost nothing, just a few stray atoms drifting over unimaginable distances, and the faint whisper of the cosmic microwave background, the afterglow of the Big Bang, too faint for human senses to detect. And even that void is not truly empty. Quantum physics suggests that particles flicker in and out of existence everywhere, even in darkness. The vacuum itself has a subtle energy, a gentle background hum of virtual particles appearing and vanishing. Space, even at its most desolate, is alive with possibilities. The silence is complete. Even if you could scream, no sound would travel in the emptiness. All that exists is the quiet hum of your own thoughts and the gentle sense of infinity stretching out. Time in such a place seems to slow to a crawl because there are no changes to mark its passage. You might feel as though you've stepped outside the busy universe into a timeless sanctuary of calm. This arrow of time suggests a kind of one-way journey for the universe as well. The cosmos began in a state of low entropy, a hot, dense beginning where matter and energy were tightly ordered. Ever since, it has been expanding and cooling, moving toward higher entropy. As the eons pass, stars will keep burning their fuel, and eventually all starlight will cease. Long before that final darkness descends, the grand tapestry of the cosmos will have changed in remarkable ways. In tens of billions of years, most galaxies beyond our local cluster will have slipped beyond our cosmic horizon, carried away by the accelerating expansion faster than their light can reach us. Our own local group of galaxies, including the Milky Way and Andromeda, will coalesce into one great merged galaxy, while the rest of the universe's galaxies fade from view. To any observers in that distant epoch, the night sky would no longer be a rich expanse of countless galaxies. It would be nearly empty, their isolated galaxy floating in a void, unaware that a vast cosmos once lay beyond, now unreachable. Trillions of years from now, the last red dwarf stars will fade to black. Stellar remnants, like white dwarfs and neutron stars, will cool down to just cold, dark cinders. Black holes, over an incomprehensible span of time, will evaporate away, particle by particle, until even they vanish. Perhaps in the final moments of a black hole's life, it would release a faint burst of energy, a last whisper of light, before quietly ceasing to exist. That could be the final fleeting flash in an otherwise darkened cosmos. What will remain then is a thin soup of particles and diffuse radiation, so cold and spread out that it is barely above absolute zero. This is the scenario often called the heat death, or big freeze of the universe, a state of ultimate entropy, where all differences in temperature and energy are gone. In that future, nothing happens in any recognizable sense. No stars shine, no new structures form. It is a cosmos in permanent quietude, essentially asleep in endless night. In such a state, time itself might lose its meaning, for with no events or changes, there is no distinguishing one moment from the next. The arrow of time would have effectively come to a standstill in a silent, timeless expanse. This fate, as far off and impersonal as it is just one possibility among others that scientists have contemplated. Another speculative ending is something called the Big Rip. This would occur if the mysterious dark energy driving the universe's expansion were to grow ever stronger over time. In our current universe, dark energy causes space to expand faster and faster, but it still only affects objects on the grandest scales. Galaxies far apart are pushed away from each other. In a Big Rip scenario, however, the repulsive force of dark energy would become so potent that it eventually overcomes all other forces, no matter the scale. Billions of years in the future, it might tear galaxy clusters apart, then shred individual galaxies, and eventually rip solar systems to pieces. In the final moments before such a cosmic rip, even stars and planets could be pulled apart as space stretches relentlessly. It's a dramatic end. The fabric of space racing outward so quickly that everything dissolves into isolated, fundamental particles. This idea is highly speculative, and current evidence doesn't indicate that dark energy will behave in such an aggressive way. But the possibility lingers as a reminder of how little we truly know about the far future. On the opposite end of the spectrum is a fate known as the Big Crunch. This would be the outcome if the expansion of the universe were one day to slow down and reverse. Instead of flying apart forever, galaxies would begin to draw closer together under gravity's pull. Over extremely long times, all matter might converge as the universe contracts. As this contraction progresses, the visible scenery of the cosmos would drastically change. Galaxies that were once gently receding would now begin rushing toward one another. The night sky would grow more crowded with stars and galaxies as they draw nearer over billions of years. Light from distant objects would shift to bluer, more energetic wavelengths as they approach, so the sky would gradually brighten. The cosmic microwave background, today a faint, cold glow, would intensify and heat up, turning from invisible microwaves to a dim red shine, then to a blinding fire that fills the heavens. It would be as if the universe were rewinding, growing hotter and denser as it shrinks, like a film of the Big Bang played in reverse. Ultimately, everything would collapse into a state perhaps similar to the origin of our universe, a hot, dense point. Some have imagined that at that moment, all the compressed energy could trigger a new Big Bang, creating a new universe all over again. In this way, the cosmos could be cyclic, expanding and then contracting in turn, each universe giving birth to the next in an endless series of cosmic rebirths. While current observations of dark energy make a big crunch unlikely in our universe, it remains a thought-provoking possibility. It paints a picture of a cosmos that is not a one-time event, but an eternal, breathing entity, with each cosmic death leading to a new genesis. Considering these possible endings of the universe, all of them unfolding over trillions upon trillions of years, one cannot help but feel a sense of awe. It also reminds us that our own lives are incredibly brief in comparison to the lifespan of a star or the age of the universe. Our decades on Earth are like a single heartbeat in the lifetime of a galaxy. But that brevity also makes our experience uniquely precious. We are here now, at this very juncture of cosmic time, able to witness the universe while it is full of light and life. Like fireflies glowing for a single summer night, we shine our consciousness onto the universe for a little while, adding our own flicker to the grand story. And in that flicker, we observe, we love, we wonder. We make the moments count. These scenarios remind us of the vast ocean of time that stretches beyond our comprehension. And yet here we are, tiny, ephemeral beings alive right now in this particular chapter of the cosmic story. In the face of such immensity, one might wonder, what is our place in all of this darkness and grandeur? Our place may be small, but it is not insignificant. We are made of this universe. Every atom in our bodies has a cosmic pedigree. The calcium in our bones was forged in the heart of a star that lived and died before the Earth was born. The iron in our blood was created in a stellar explosion that scattered it across space before new stars and planets formed. Even the oxygen we breathe and the carbon that forms the backbone of life were brewed in the nuclear furnaces of stars billions of years ago. In a very literal sense, we are children of the stars. We are the universe in tiny conscious pieces, pondering itself. Think about that. After billions of years of cosmic evolution, the expanding clouds of gas and dust coalesced into stars, planets, and eventually life. And one form of that life, us, can look up at the night sky and reflect on the very process that made it. We peer out into the darkness and try to understand black holes, dark matter, the fate of the cosmos. And by doing so, the universe is gazing back at its own image in a mirror. Through our curious minds, the cosmos has become aware of itself. We are not the first to be mesmerized by these questions. Generations of scientists and dreamers have gazed upward and let their minds wander among the stars. Albert Einstein once conducted thought experiments in his imagination, chasing beams of light in his mind, to uncover the nature of time and space. Stephen Hawking spent a lifetime delving into black holes with the power of intellect alone, expanding our understanding of how the universe might work at its extremes. Their bodies were rooted on Earth, but their thoughts travelled to the edges of space and time. In a similar way, here and now, our thoughts have journeyed far beyond our physical selves, touching distant corners of the cosmos. This ability to imagine, to explore in our minds, is a gift of consciousness. As you listen, you too are engaging in that grand tradition of cosmic contemplation, becoming, in a sense, an explorer of the universe from the quiet comfort of your room. Our thoughts and questions are like tiny lights flickering against the vast, dark backdrop, illuminating just a little of the mystery. After all those eons of cosmic history, here we are, contemplating the cosmos together. Each question we ask, and each discovery we make, is a spark of light in the dark, adding to the ever-growing constellation of human knowledge and curiosity. It's true that much of the cosmos is dark, filled with invisible matter and energy, sprinkled with isolated islands of light. But darkness is not something to be feared here. It is the canvas on which the stars paint their bright story. It is because space is dark and mostly empty that the jewels of the night sky shine so clearly for us. The darkness, in its own way, gives form to the light. Even the cosmos's history reflects this truth. For hundreds of millions of years after the universe began, there were no stars at all, and space was unillumined. Only after those dark ages did the first stars ignite, piercing the cosmic night with their newborn glow. Light was born from darkness, and ever since, the two have complemented each other, each defining the other. On our little blue planet, night falls and reveals a sky full of stars. That darkness above, the quiet night we experience, is a direct connection to the greater universe. When you stand under a moonless sky and look up, You are gazing into the deep cosmic ocean, into the same darkness that fills the space between galaxies. In that moment, the boundary between our world and the wider universe dissolves. You might feel a cool breeze or the gentle hush of night, and you realize that the air you breathe and the ground beneath your feet were born from cosmic processes. Earth is a tiny haven of light and life, an island in a vast, dark sea of space. Yet, here on this island, we can look out and feel at home in the universe. We can find beauty and peace in knowing that the night sky's darkness is our window into everything beyond. And when you gaze at the stars, you are also looking back in time. The faint glow from a distant star might have left that star's surface thousands of years ago, long before you were born, and only now has it arrived for your eyes to witness. In that sense, stargazing is like reading an ancient cosmic history book, where each point of light is a story from long ago traveling far and wide to reach you. Those stars twinkle distantly, each one a sun that might host planets and maybe even other beings looking up at their night. We cannot know for sure, but it's comforting to think that in the vast galaxy there could be others gazing at their skies, pondering the stars, and feeling the same sense of wonder. In that way, the darkness of the universe connects us all across time and space. Throughout this journey, we have ventured into cosmic mysteries and let our minds wander through realms unseen. We marveled at invisible dark matter, the hidden mass holding galaxies together. We felt the expansive push of dark energy, stretching the fabric of space and accelerating the universe's growth. We imagined mirror universes and higher dimensions beyond our perception, wondering if shadows of our reality dance in parallel. We dared to ponder a multiverse, envisioning our cosmos as just one of countless bubbles in a greater existence. We gazed into the abyss of black holes and witnessed the bending of space and time at the edge of an event horizon. We contemplated the flexibility of time itself, how it can slow and twist under gravity's influence. We drifted through silent voids, those immense stretches of nearly empty space, and we speculated about the final twilight that might one day fall over all things. All of these mysteries, disparate as they seem, share a common effect on us. They fill us with wonder. They remind us that even in darkness and uncertainty, there is beauty and a profound calm. It is humbling and comforting at once. The universe is vast and mostly unknown, yet we have the privilege of experiencing it, questioning it, and finding our place within it. In the face of cosmic mystery, we do not feel lost. Instead, we can feel at home, as if the darkness were a soft blanket rather than an abyss. There is peace in not knowing everything, in understanding that some questions might not be answered in our lifetimes or ever. The unknown is not a void to fear, but a frontier to gently admire from our little corner of existence. And so, under the same dark sky that has spurred humanity's imagination for countless generations, people have gazed at the night sky and wondered what lies in the darkness between the stars. Ancient farmers, sailors, and storytellers watched the constellations and wove myths about gods, animals, and heroes in the sky. The Great Bear, the mighty hunter, a soaring eagle, a celestial river, such shapes were traced among the stars, each culture filling the darkness with its own stories. Many saw the Milky Way as a path of souls or a spilled ribbon of milk across the heavens. Without modern instruments, they still sensed a grand design in the night and felt the power and mystery of the cosmos. In a way, when we ponder the universe today, we are continuing that very old story, adding new chapters of knowledge to an ancient book of wonder. And just like our ancestors, we find meaning and solace under the stars. Now, we let these thoughts quiet down. The hour is late, and the cosmos is keeping watch as it always has. In just the last century or so, our scientific understanding of the universe has expanded rapidly. We discovered that our Milky Way is just one of countless galaxies, and that the universe began with a fiery birth and has been expanding ever since. We learned of the astonishing power of gravity, predicted the existence of black holes long before we ever saw one, and unveiled invisible ingredients like dark matter and dark energy that govern cosmic evolution. Each breakthrough answered old questions and raised new ones. Not long ago, the idea of an expanding universe or millions of galaxies was unimaginable. Now these are fundamental truths. Yet the more we uncover, the more deep mysteries seem to appear on the horizon. We find that our progress is like climbing a mountain. The higher we go, the more expansive the vista, and the more there is to explore. We are participants in an ongoing journey of discovery that connects us with generations past and future, each looking up in wonder at the night sky and trying to fathom the nature of everything. Through our curious minds, the cosmos has become aware of itself. By exploring and understanding, we give the universe a chance to know itself through us. The hour is indeed late now, and above us, the quiet stars have been keeping their watch. The stars twinkle distantly in their quiet vigil overhead. We breathe in the cool night air and breathe out the worries of the day, allowing ourselves to sink into the natural tranquility that the night provides. In this moment, you can imagine yourself floating among those stars, weightless and free, carried by the gentle currents of space. Above you, the arch of the Milky Way glows faintly, and all around is the comforting darkness of the universe. You are safe here, a child of the cosmos, cradled by the very forces that forged you and all you know. The beat of your heart is like the slow pulse of the universe, steady and calm. As you drift in this imaginary cosmic sea, you feel a deep connection to everything around you, a unity with the stars, the spaces between them, and the very flow of time. Let your mind drift as well. There is no need to hold on to any particular thought. They can come and go like gentle waves. The universe is a grand, intricate tapestry, and right now, you are a quiet observer, wrapped in its folds. Feel the peace that comes from knowing that the cosmos, in all its vastness, simply is. It unfolds on scales of space and time, far beyond our daily concerns, and yet here you are, an intimate part of it all, resting in its embrace. The dark side of the universe has shown us wonders and posed questions without answers, but it also offers a lullaby of mystery. In the silence of these late hours, that lullaby sings softly. It tells us that it's okay not to know every secret, that there is serenity in the great unknown. It whispers that the same darkness that surrounds distant galaxies also enfolds you as you close your eyes. So now, as you prepare to journey into sleep, feel the weight of your body melt into your bed like a fragment of stardust settling back into the night. Let the calm of the cosmos wash over you. Your breathing is slow and rhythmic, a mirror to the gentle expansion of the universe. With each breath out, you release tension. With each breath in, you draw in the cool tranquility of space. Any remaining tightness or worry eases, flowing out of you and away. Take a slow, deep breath. As you exhale, bring your attention to your feet and toes and allow them to soften and let go. Imagine any tightness there evaporating into the darkness like mist. Now feel relaxation rising into your calves and thighs. Your legs grow warm and pleasantly heavy, sinking comfortably into your bed as if gravity is wrapping them in a gentle embrace. Let go of any tension in your hips and lower back. Feel that area slacken and become weightless. Move your awareness up to your stomach and chest. With each slow breath out, release any knots or fluttering there, letting your belly soften and your breath flow freely. Your chest feels open and calm, your heartbeat steady and untroubled. Now, release your shoulders. They have carried the weight of your day, and they deserve to relax. Envision them easing downward, loosening as if a burden is being lifted off. Let the relaxation flow down your arms, through your elbows and forearms, all the way to your hands and fingers. Your arms become loose and limp. Your hands rest peacefully by your sides, fingers gently curled without any effort. Perhaps you feel a slight comforting tingling, energy flowing as every muscle lets go. Finally, bring your attention to your neck, head, and face. Unclench your jaw, allow a small gap between your teeth, and feel the jaw muscles soften. Smooth your brow. Let your forehead become as serene as the surface of a calm, dark sea. If your eyes haven't already closed, allow your eyelids to softly fall, shutting out the last slivers of light. Even the tiny muscles around your eyes let go, any remaining tension melting away. Your entire face is relaxed and at ease. From the top of your head to the tips of your toes, your body is now completely at rest, settled and quiet. Above, the universe stretches on, dark and deep, filled with the echoes of all the stories we've whispered tonight. Black holes slowly spin in the void, each one a silent vortex that may last trillions of years, imperceptibly whispering away its mass in faint, hawking radiation. Time flows ever onward, an invisible river carrying all worlds and beings into the future, even as we let go of the present moment and drift into slumber. Galaxies continue their majestic dance, their spiral arms sweeping through space, while they themselves drift farther apart, like serene dancers moving across an endless stage. Somewhere, in a distant quiet corner, a star is ending its life in a gentle farewell, collapsing and sending out its remnants to become the building blocks of new stars and planets. In its final act, it may leave behind a small black hole, a parting gift of mystery for the future cosmos. Everything is in its place, and all is well. In this vast cosmic night, you are not alone. You are part of something endless and wondrous. Feel that comfort, that connection. Let your eyelids grow heavy with that knowledge and that peace. As you drift towards sleep, know that the universe drifts with you, that every atom in your body resonates with the lullaby of the stars. We end our journey here, floating gently in the dark side of the universe, which now doesn't seem so dark after all. It feels like a homecoming to a place we have always belonged. Perhaps, in your slumber, you will find yourself floating in a cosmic dreamscape, You might glide along the gentle glow of a nebula, or stand on an ethereal shore watching stardust waves lap at the cosmic night. In dreams, you could touch the rings of a distant planet or follow a comet as it sails silently by. All the while, you are calm and safe, surrounded by the same wonder that fills your waking thoughts. May your dreams carry you through galaxies and across event horizons, safely and serenely. May you find rest and restoration in the cosmic night. Perfect. I'll create part 3 of The Dark Side of the Universe as a richly detailed, dreamlike continuation, blending deep scientific themes, imagined cosmic narratives, and philosophical metaphysics. It will exceed 10,500 words for a runtime of 1 hour 20 plus minutes, maintaining the same slow, soothing, and mysterious tone throughout. I'll let you know when it's ready for you to enjoy. In the silent embrace of the cosmic night, we drift onward, weightless and free. Stars glimmer faintly around us, like distant lanterns in an endless void. The Milky Way forms a pale, silken band above, a congregation of countless stars whispering light across the ages. Nebulae, wisps of cosmic cloud, glow softly in pastel hues far off, and an occasional shooting star streaks silently across the abyss. We feel completely at ease, floating without effort, as though buoyed by the very fabric of space. There is no rush here, no sense of time pressing forward, only the eternal now of space. Our journey continues through the darkness, gentle and unhurried, as if we are floating on a calm, cosmic sea. We are cradled by the universe itself, each breath in sync with the slow expansion of galaxies, each heartbeat echoing softly into the vastness. Now, in this moment, there is nothing you need to do except drift and listen. Starting at your toes and feet, allow a wave of relaxation to flow upward. Feel your legs soften and your belly unclench. Let your shoulders drop, your hands rest easy, your jaw release. With each breath out, your body sinks deeper into comfort and your mind becomes quieter. Take a slow, deep breath, and as you exhale, allow any remaining tension to melt away into the darkness around you. Your eyelids are soft and heavy. A cozy drowsiness is wrapping around you. We are safe here, gently floating in the cosmic ocean, open to whatever wonders may come. Imagine, for a moment, that we could go back to the very beginning of everything. Before the stars, before even darkness had meaning. There is a deep hush, a profound nothingness, pregnant with potential. And then, in an instant beyond time, a burst of creation blooms. It is cosmic inflation, the universe's silent thunderclap. Space itself unfurls at a mind-boggling rate, faster than the speed of light, faster than thought. What was once smaller than a grain of dust expands to astronomical scales in the blink of a cosmic eye. Yet there is no sound, no fireball as in later imaginings of the Big Bang, only the rapid stretching of space-time, like a balloon inflating in a dark room. It is the universe blossoming like an unimaginable flower, a cosmic lotus opening its petals of space in an instant. In this fleeting fraction of a second, the seeds of all that will ever exist are sown. Tiny quantum ripples, imperceptible and random, are blown up to galactic proportions. These ripples will become the clusters of galaxies and great voids between them, eons later. Within that primordial expansion, time itself is a newborn. A moment ago, moment meant nothing at all. Now, there is a before and an after. The universe is still almost featureless, a hot, dense haze, but cosmic inflation has given it a uniformity and a vastness that defies comprehension. It's as though the cosmos took a deep, sudden breath, and as quickly as it began, the inflationary burst eases and fades, leaving a young universe, still expanding, but now at a calmer pace. In the afterglow of this event, the energy of that expansion transforms into a burst of light and particles, the hot Big Bang that follows, filling the universe with a brilliant fire. We drift as silent witnesses to those first moments. In our mind's eye, we see an afterglow suffusing everything, a warm, diffuse light bathing the infant cosmos. This is the cosmic microwave background, the faint echo of the Big Bang's heat, a gentle glow that even now, billions of years later, still lingers in the darkness as a whisper from that time. A glow that once was blindingly bright has been stretched and cooled. As the universe expanded and thinned out, that blinding white-hot light shifted to soft red, and then beyond visibility, stretching into microwaves. But it remains everywhere, filling space with a quiet warmth. It is as if the universe carries memories of its childhood in this dim halo of light, a uniform murmur from creation's dawn, darkness upon darkness, lit by the first light. As we float through this memory of light, the passage of time accelerates in our story. We watch the universe expand and cool. For a time, even after the brilliant glow, there are not yet any stars, only darkness and vast, cooling hydrogen fog. The cosmos, having released its initial flash, enters a deep night once more, a cosmic dark age, a calm anticipation before the first dawn of starlight. Gradually, gravity begins gathering the diffuse gas into dense patches. After millions of years, at last the first stars ignite. The fog of early plasma clears like mist lifting at sunrise, and the cosmos becomes transparent. Darkness is no longer absolute. It is now sprinkled with the earliest stars, igniting like tiny candles in a limitless night. Those stars gather into nascent galaxies, pulled together by gravity, much of it provided by invisible dark matter forming vast halos around them. And thus the large-scale structure of the universe takes shape, galaxies like islands in a sea of emptiness, with vast gulfs of space between. Eons pass in our gentle journey. We witness the majesty of cosmic evolution unfolding in slow motion. Stars live and die. Galaxies collide and merge in slow dances, their starry arms intermingling gracefully. From our distant view, such collisions are not violent crashes, but gentle interweavings. Stars seldom hit directly. Instead, they sweep past each other, stirred into new orbits. Sometimes great tidal streams of stars get drawn out, forming luminous bridges between merging galaxies, like gossamer threads connecting them until they eventually settle as one. New galaxies form from the old, and the cosmos grows more structured and diverse. We observe stars being born in cosmic nurseries, vast colourful nebulas where gas and dust clump and flare into light. We watch ancient stars swell into red giants and shed their skins, or collapse and explode. A supernova may be an immense explosion, but from afar it blooms like a luminous flower, spreading heavy elements into space which will seed new worlds. And not all stars die with such fury. A sun-like star perishes more gently, shedding its outer layers in shimmering shells. These expanding clouds form planetary nebulae, cosmic blossoms of gas that glow for millennia before fading. They are like celestial lanterns marking a star's peaceful passing, beautiful and serene. Out of the enriched remnants of these stellar lives, new stars and planets will eventually coalesce. From those recycled ashes, the building blocks of life, carbon, oxygen, iron, are scattered and sown. From those enriched clouds, new solar systems will form. On at least one small planet, our Earth, these elements joined to create living beings who one day would look back up and understand where they came from. Perhaps, scattered across the galaxy, on other worlds, life has blossomed too, gazing at the night sky with the same wonder. Now, as we continue, our thoughts turn to the unseen spaces beyond what we can directly witness. The universe is vast, but what lies outside the edge of what we know? Some say there might be no edge at all. Perhaps space goes on forever. Others propose that our universe is just one bubble among countless others. During that wild inflationary birth, maybe other regions ballooned into their own universes, separate from ours, unreachable and unseen. We picture it, an infinite expanse of cosmic foam, each bubble a universe unto itself. In some bubbles, physics might take a different tune, different particles, forces, even dimensions. They drift apart, never to meet, each expanding into its own space and time. Each of these universes could have its own story. Perhaps in one, galaxies form and life blooms under alien physics, while in another, stars never ignite and darkness reigns. Some might collapse again quickly. Others might expand forever. The possibilities span beyond anything we know, each bubble a variation on existence itself, isolated by vast expanses of inflating space. This idea of a multiverse is speculative, a whisper of theory at the fringes of science, but it tickles the imagination. It reminds us that reality could be far grander and stranger than our minds, bound by our single universe experience, can easily grasp. In fact, our cosmic inflation theory suggests this process might be endless, an eternal inflation, where new universes sprout like bubbles in a never-ending foam. Yet as we drift here in the calm dark, even the notion of countless other universes feels serene. They are like distant possibilities, humming softly beyond our reach. If they exist, they do not intrude on our cosmos. They blossom in their own realms, each following its own path. And so we let them be, like lanterns flickering beyond a far horizon, while we remain in the gentle night of our own universe. We may never verify these other realms, but just contemplating them stretches our perspective. It makes our own universe feel both vast and strangely intimate. Vast, because it might be one of countless others. Intimate, because it reminds us that even our reality is part of something larger, an infinite sea of possibilities. we turn our attention back to the space around us, the space that seems so empty and still between the stars. To the eye, it appears a perfect vacuum, a void without a whisper of matter or light. It feels calm and silent, the way a midnight desert might feel when even the breeze has fallen asleep. But we have learned that this emptiness is deceiving. Even the vacuum has its secrets. What appears to be nothing is in truth a hotbed of activity and latent energy, a silent engine room underlying reality. Within the darkness, ghostly, subtle forces are at work. Fields of energy that permeate all of space, unseen but real. In fact, it was such an energy field, existing everywhere, that drove the cosmic inflation at the dawn of time. And even today, long after that first eruption of expansion, a relic of something similar seems to linger. We call it dark energy, a mysterious pressure woven into the fabric of the vacuum, pushing the universe outward. Billions of years after the Big Bang, dark energy began to dominate, and the expansion of the universe, which had been slowing down due to gravity, started to speed up again. It's as if an invisible hand were gently pushing the galaxies apart, a slow cosmic wind that grows with time. Already, distant galaxies are being carried away faster and faster, like boats caught in a strengthening current. If this continues far into the future, galaxies will drift so far that each will be marooned in darkness, unable to see the others. For now, we hardly notice dark energy's work when we gaze at the night sky. It acts over the vastest distances. But it is the grand theme of our epoch, an accelerating cosmos, drifting ever more apart. All this points to a truth that runs through the cosmos. Even what seems empty and still can hold immense power. The quiet vacuum of space is not truly nothingness. It thrums with fields and possibilities, like a silent harp string ready to be plucked. Physicists wonder if the vacuum we live in is completely stable, or if it's perched in a delicate, temporary state. They speak of a possibility known as vacuum decay, the idea that our universe exists in a kind of false calm, and that someday it might snap, like supercooled water suddenly crystallizing into ice, into a different state altogether. In this scenario, a tiny point in space could suddenly become a seed of a new phase of reality, a true vacuum where the energy of space is lower. If such a seed appeared, it would expand outward at nearly the speed of light, like an ever-growing bubble, converting everything it touches into a new form with different physics, different rules. One moment, all is as it has been for billions of years. The next, a wave of transformation sweeps through. Galaxies, stars, planets, everything as we know it, would be changed or extinguished in the blink of an eye, without warning or pain. It is a profound thought, the universe remaking itself in an instant. Yet as we float in this serene darkness, even the end of the world as we know it feels abstract and distant. Nothing to fear. If the cosmos decides to change its state, there is no stopping it. And worrying does no good. In our meditative journey, we can face this possibility with calm curiosity. We realize that in the grand scale of time, change is the only constant. Stars are born and die. Galaxies form and fade. Even space and time themselves might transform. And perhaps, out of such an upheaval, something new and beautiful would emerge, like a cosmic phoenix rising from the ashes of the old reality. After all, our own universe's birth might have been just such an event in some earlier cosmos, a bubble of expansion appearing in an infinite field of possibilities. So rather than dread, we feel a gentle acceptance. Everything we know is precious, exactly because it is transient. Like cherry blossoms that bloom brilliantly and fall, or a shooting star that streaks the sky in a brief flash, the brevity of each cosmic stage lends it a special beauty. The universe flows onward, and we flow with it. If one day our reality must dissolve into something new, it will be a peaceful transition, happening in an instant, too quick to register. And who knows? Perhaps in that new universe, new wonders will appear, new forms of life, new consciousness under different stars. In this way, even destruction becomes merely transformation. The old quiet night would give way to a new dawn. For now, our universe holds together in its current form, and we continue our journey through it, leaving behind these musings on cosmic birth and death. We turn to look more closely at the fabric of this reality. We zoom in our imagination, deeper and deeper into the apparently empty darkness between stars. We shrink down billions of times, until even atoms tower above us, like distant galaxies once did. Here, at this microscopic scale, emptiness reveals itself to be a lively dance of flickers. At sizes a millionth of a billionth of a billionth of a centimetre, space-time is not smooth at all. It churns with uncertainty, foaming and bubbling like the surface of a distant sea seen in fast forward. This is the realm of the quantum foam, where the distinction between something and nothing blurs. At this Planck scale depth, the very concepts of before and after begin to lose meaning. Fluctuations erupt and subside so rapidly and on such tiny scales that space and time themselves become fuzzy, indeterminate. In this subatomic ocean, particles spontaneously appear and vanish in an incessant quantum drizzle. It's as if tiny fireflies are blinking in and out of existence in a midnight field. Brief sparks of being that illumine the void for a heartbeat before melting back into it. A particle and its ghostly twin, an antiparticle, might briefly emerge from the vacuum, only to annihilate and disappear a moment later. These phantom occurrences happen constantly, everywhere, so fast and so small, we never notice them directly. Yet their effects can be measured. Even in a perfect vacuum, a subtle force exists, the Casimir effect, as scientists call it, whispering of the vacuum's secret activity. If we could dive into that quantum sea, it might feel like a gentle fizz against our skin, a tingling of existence and non-existence intermingled. Time itself in this realm loses the smooth flow we take for granted. At such a fundamental level, a second is an ocean of possibilities, and cause and effect become hard to define. We imagine drifting through this quantum foam, carried by currents of probability. Little bubbles form and pop around us. Perhaps each is a minuscule space-time warp, maybe even a tiny baby universe that flares into being and then recedes. The idea has been suggested that our entire cosmos could have sprung from just such a quantum fluctuation, a random blip that inflated into the vast universe we see today. In the quantum foam, reality and nothingness constantly trade places, and from that ethereal dance, all of existence might have emerged. To bring some order to this mysterious foundation of reality, scientists have long searched for a deeper theory, a unifying principle that ties together the forces of nature and the quantum underpinnings of the cosmos. One beautiful idea that has emerged is string theory. In string theory, the myriad of particles we know, electrons, quarks, photons, and so on, are not fundamental dots, but rather tiny, vibrating strings of energy. Each type of particle corresponds to a different vibration mode of a string, much like different musical notes come from different vibrations of a violin string. Picture an unimaginably small string, trillions upon trillions of times smaller than an atom, dancing with energy. When it vibrates one way, we perceive a particle of matter. When it vibrates another way, we perceive a particle of light, or gravity, or any other. In essence, the universe could be made of music, an orchestra of strings playing the symphony of creation. The laws of physics would then be the harmonies and melodies these strings can play. Gravity, electromagnetism, the forces that bind the atomic nucleus, each would be a different motif in the cosmic composition. It's a poetic vision. The ancients spoke of a cosmic sound. In Hindu thought, the primordial Om that birthed reality. In Western tradition, in the beginning was the Word. One might even recall the Greek idea of the music of the spheres, the celestial harmony Pythagoras imagined from the movements of planets and stars. In a sense, modern physics echoes these sentiments with mathematics. The world arises from vibrations. It is as if the cosmos has a hidden soundtrack, a foundational tone on which all existence is built. String theory also suggests that the stage on which this music plays is more elaborate than we thought. Our senses tell us we live in 3 dimensions of space: up, down, left, right, forward, backward, and one of time. But the equations of string theory only work elegantly if there are additional hidden dimensions curled up within the fabric of reality. There might be 6 or 7 extra spatial dimensions, folded so tightly that we cannot move through them or see them in our everyday life. It is difficult to picture, but we can try an analogy. Imagine living on a flat sheet of paper, a 2-dimensional world. You know length and width, but no concept of height. If a 3-dimensional object, say a sphere, passed through your 2D world, you'd see it as a shape-changing size, a circle growing then shrinking, never realizing its full 3D form. In the same way, higher dimensions might elude our perception. They are like tiny, secret rooms at each point in space, too small for even a particle to enter, yet influencing the way the strings vibrate and weave reality. We might only catch shadows or effects of them. Perhaps occasionally, in the behavior of subatomic particles or the force of gravity, these hidden dimensions make themselves known in subtle ways. We can imagine each point in space containing a miniature labyrinth of curled up directions, perhaps shaped like an intricate origami or a delicate knot. Within those tiny spaces, the strings vibrate and pattern themselves into what becomes our visible universe. It's a strange thought that right here, in the space around you, there could be hidden directions, entire arenas of reality folded in on themselves. If we were small enough, or if we could somehow unfold those dimensions, we might wander through them and find that our universe is just a surface or membrane floating in a higher dimensional expanse. Indeed, string theory gives rise to the idea of brains, short for membranes, vast, flexible sheets of reality. Our own universe could be one such brain, a three-dimensional surface adrift in a larger cosmic space with more dimensions. Other brains might float alongside ours, unseen and untouchable unless they collide. Some visionaries have imagined that the Big Bang itself was caused by such a collision. Two brains brushing against each other in the higher dimensional space, releasing a burst of energy that became a new universe, ours. If that is true, then perhaps creation is not a singular event, but a repeated occurrence. Brains might collide again and again over eternities, sparking new universes each time, like cymbals clashing repeatedly in a grand cosmic orchestra. For a moment, we can envision these colossal membranes, endless ethereal planes drifting in a greater void. When they touch, energy flows into the point of contact, inflaming it with unimaginable brilliance. We could imagine that point blooming into a fireball, an entire universe springing into being from the collision. These ideas remain speculative, but they paint a picture of a reality rich with layers, where what we perceive is only one section of a much vaster multidimensional tapestry. All of this exploration, from quantum foam to string vibrations and hidden dimensions, leads us to marvel at how mysterious and boundless the cosmos is. Even as we find explanations and equations, new questions open up like endless halls in a house of mirrors. But rather than feeling lost, we can feel at home in this enigma. Mystery is not something to solve and then discard. It is something to experience, to savor. In the darkness of our unknowing, there is wonder and room for imagination to play. We take comfort in that vast unknown, because it means the story of the universe is far from over. There are infinite possibilities yet to unfold, and countless tales yet to be told by the stars and whatever lies beyond them. For a moment, we let all these grand notions settle. We simply float and observe the beauty around us. Nearby drifts a pale blue nebula, its shape like a delicate flower made of smoke, tendrils of stardust curling and branching. It glows gently from within, where a cluster of baby stars is being born. Its light reaches us as a soft, watercolor shimmer against the dark. Though the processes within it span millions of years, in our tranquil observation, it appears almost motionless, a cosmic blossom frozen in time. In another direction, we see the faint outline of a distant spiral galaxy, its graceful arms dotted with the light of billions of suns. We know that the light reaching us left that galaxy eons ago. We are gazing deep into its past. Perhaps within it, civilizations rose and fell, while that gentle glow travelled across the intergalactic sea. Yet here it is now, a soft beacon in our night, a reminder of how time and distance intertwine. Here in the quiet of intergalactic space, we are suspended between these wonders. No sound reaches us, but the sight itself is like music, a silent aria of light and form. We take it in, letting our thoughts dissolve into this vista. The mind is still, only awareness and awe remain. In this silence, we feel connected to everything. The newborn stars in that nebula, the ancient stars in that far-off galaxy, and the dark space between, all part of one majestic panorama. After a while, softly, new thoughts and questions drift back into our awareness, and we continue our journey of the mind. We have journeyed through the smallest scales and the hidden dimensions of existence. Now our thoughts turn to one of the most profound mysteries of all, the nature of time itself. Time, which carries us ever forward and turns present into past in the blink of an eye, is our constant companion. But what is it, really? We feel it flow like a river, yet modern physics tells us time can bend and stretch, and perhaps even loop back on itself in extraordinary circumstances. In Einstein's relativity, time and space are woven together, and both can warp in the presence of mass or motion. A clock on a speeding spaceship will tick slower relative to one at rest. Near a massive object like a star or a black hole, time itself runs more slowly compared to far away and emptier space. This has been measured and confirmed, a testament to time's flexibility. So time is not absolute. It is part of the fabric of the cosmos and can be reshaped by gravity and speed. If time can stretch and shrink, could it also fold in such a way that it forms a loop? Some solutions to Einstein's equations suggest it might be possible. Imagine a universe that rotates, or a wormhole, a hypothetical tunnel through space that connects back to its own past. In such strange geometries, one could, in theory, travel in a closed, time-like curve, a path that eventually circles back to the starting point in time, not just space. It is a perplexing idea, a time loop where cause and effect tangle together like a serpent eating its tail. In a loop of time, there is no clear beginning or end. Events wrap around and perhaps repeat. What would it feel like to be caught in time's loop? Perhaps it would be like rereading a beloved chapter of a book over and over, with only faint déjà vu to mark that you've seen these events before, or like a melody that resolves to its starting note, ready to play again, over and over. Imagine coming upon a shimmering cosmic doorway, a wormhole glowing softly in the darkness. We feel curious and drift into it, allowing space and time to twist around us. Inside the wormhole, space feels fluid. The familiar pinpoints of stars smear into soft trails of radiance. Colours we have never seen shimmer at the edges of our vision as the fabric of reality bends. There is a gentle, tingling sensation as the tunnel carries us and then releases us into open space again. Looking around, we sense something astonishing. We have arrived not only in a distant place, but in an earlier time. The galaxy here seems oddly familiar, yet younger. Star clusters that were dim and aged appear fresher, and nebulae that had vanished are present again. We realize we have stepped into the past. Perhaps, if we sort them out, we might even find younger versions of ourselves, somewhere in this universe, gazing up at the stars, unaware of our presence. The thought is strange and wondrous. Instead, we choose simply to observe the cosmic scenes anew. We watch a distant star live through its cycle, swelling into a red giant, and then collapsing in a final burst of light, a supernova that blossoms quietly like a slow-motion flower across the sky. When that brilliant display fades, we slip through another loop and find ourselves back before the star had exploded, witnessing the starlight as it was earlier once more. It's as though we rewound time, experiencing a cosmic event again. In this loop, there is no anxiety or rush, only a profound insight that time's arrow can bend back on itself. We drift out of the loop, returning to the normal forward flow of time, carrying the knowledge that even time can form circles. This brings us to the idea of cyclical time on the grandest scale. We have seen how the universe began, at least in our best theories, with a furious expansion and a hot, dense state. But is the Big Bang truly the beginning of everything? Or was it just the start of our current chapter, preceded by others we cannot see? Could the universe go through endless cycles, an eternal series of bangs and crunches, expansions and contractions, like the beating of a timeless heart? In earlier decades, scientists imagined an oscillating universe, one that expands outward from a bang, slows down, stops, then recollapses under gravity in a big crunch, only to rebound in a new Big Bang, repeating the process. In such a scenario, we could picture the sky slowly filling with light as galaxies draw back together. Over billions of years, everything would converge until all matter and energy compress into a single point. A furious furnace brighter than 1,000,000,000,000 suns. Then, in an act of cosmic rebirth, that point would erupt again, dispersing energy and matter to form new stars and galaxies. It would be as if the universe exhaled and then inhaled, over and over, without end. Our modern observations, however, suggest the expansion is speeding up due to dark energy, making an eventual contraction seem unlikely for our universe. And yet, other cyclical models have been proposed. Perhaps, in some far future, the very fabric of space-time will thin and fluctuate enough to trigger a new burst of inflation, a new creation event that starts the story anew. Or perhaps, as the universe expands towards near emptiness, it reaches a state indistinguishable from the primordial simplicity, allowing a new Big Bang to effectively arise from the nothingness that is everything. One radical idea is that if the universe expands indefinitely, the notion of time might lose meaning when nothing changes anymore. In the eternal stillness of a heat-dead cosmos, time could become so dilute that a new spark of something effectively restarts the clock, a phoenix universe born from its own ashes. Another idea suggests that new universes might bud off from old ones through black holes or quantum fluctuations, each black hole perhaps containing a tiny embryo of a cosmos, hidden behind its event horizon, waiting to expand in a separate reality. In these conceptions, time is like a circle or a spiral. It might revisit similar places, but each cycle could be a little different, like variations on a cosmic theme. These modern cosmological musings strangely echo some of the oldest spiritual and philosophical ideas humanity has held. Ancient Hindu cosmology, for instance, speaks of the universe going through infinite cycles of creation, preservation, and dissolution. In that view, there was never a first beginning, nor will there be a final end. Only the eternal breathing of existence, expanding and contracting, sleeping and awakening, without cease. They imagined vast timescales, kalpas, where each cycle spans billions of years. Uncannily close to the timescales we discuss in cosmology today. In those legends, the universe is born from the breath or dream of a divine being, and withdrawn again in another breath, over and over, eternally. Similarly, the concept of the Ouroboros, the snake swallowing its tail, symbolized the eternal return, the cycle of endings and beginnings feeding into each other. The Stoic philosophers in ancient Greece also contemplated an eternally cyclic cosmos, periodically consumed in fire and reborn. Norse myth envisioned the world ending in Ragnarok and being born anew, and the phoenix in Egyptian and later myths rises reborn from its ashes, just as the sun rises again after each night. Even the dark patches of the Milky Way were given meaning. Aboriginal peoples of Australia looked up and saw not only the bright stars, but the shapes formed by the starless voids between them. One famous shape is the emu in the sky, outlined by the dust lanes of our galaxy. To them, the darkness itself was a story, a living presence among the lights. These ancient stories, whether of a universe hatched from a golden egg, a god dreaming the world, or a phoenix rising from ashes, carry a profound intuition that creation and destruction are connected in an eternal cycle, that the end of one story is the beginning of the next. Even as science today answers questions with new precision, the feeling we get under a sky full of stars is the same wonder those early storytellers felt. The language has changed, but the awe remains. As we float here in the quiet darkness, we can almost sense that grand cyclic rhythm. Perhaps it is in the faint background glow of the universe, or in the way galaxies seem to form patterns that repeat at different scales. Or maybe it lives in our own heartbeat and breath, which hint that life moves in cycles, inhale and exhale, wakefulness and sleep, the turning of days and seasons. We find comfort in the idea that nothing is truly lost, that even the darkest, longest night is followed by dawn. If the universe has a night, an epoch of stillness or collapse, it may yet be followed by a new cosmic morning. If time is a circle, then in some sense, the stars and galaxies we see might not be the first of their kind, and perhaps not the last. Now, having contemplated the vast arcs of time and the fate of universes, let us gently turn our gaze inward, to the small and the personal, to the mysterious light of consciousness that illuminates all these ponderings. Here we are, tiny sentient beings on a small planet, drifting through all this immensity. And yet, through the gift of consciousness, we carry within us a kind of universe of our own. The brain inside your head, quiet as it may be in this moment of rest, is composed of tens of billions of neurons, firing in patterns more intricate than the dance of galaxies. It's often said that the human brain is one of the most complex structures known in the universe. In the mystical aphorism, as above, so below, we find a resonant truth here. The macrocosm of the universe and the microcosm of the mind reflect one another in complexity and wonder. Our thoughts, dreams, and awareness form a cosmos within, full of memories and imagination, fears and hopes, as vast in its own way as the outer cosmos is in extent. Think of this. The atoms that make up your body were forged in the hearts of ancient stars that lived and died long before the earth was born. Every cell in you carries chemical elements: carbon in your cells, calcium in your bones, iron in your blood, that were brewed in stellar furnaces or created in titanic supernova explosions. We truly are made of star stuff. In that sense, the universe is not just around us, it is within us. The very substance of our being is a direct link to the cosmos, and our consciousness, which arises from this material, can gaze out and comprehend the cosmos. It is as if the universe has awakened through us to look upon itself with wonder. In our wonder and curiosity, the cosmos finds a mirror to admire its own splendor. Perhaps that is one subtle purpose of conscious life, to give the universe something to converse with, a way to behold its own majesty. We are a way for the cosmos to know itself, to feel its own grandeur on an intimate, living level. Such thoughts can shift our perspective on what the self is. We often feel so separate, a lone mind trapped in a body, looking out at an external world. But consider how deeply interconnected we actually are with everything around us. The air you breathe, the water you drink, the food that becomes your body, all were part of the environment moments before, part of other living beings, part of the sky and sea. The boundary between you and the rest is porous. With each breath, we trade atoms with the atmosphere. In fact, the air in your lungs now likely contains atoms exhaled by both dinosaurs and saints, Julius Caesar, and distant future children. It's all one shared reservoir. With each meal, we incorporate minerals and molecules that have cycled through countless forms of life on Earth. Physically, we are not isolated islands. We are constantly exchanging substance with the world. Even our minds are not as independent as we think. Our ideas, language, and knowledge all come from others, passed down through culture, or gleaned from interactions with the world. We are patterns in a broader fabric, like whirlpools in a river. A whirlpool looks like a distinct entity as it swirls, but it is just water in motion, borrowing substance from the river and eventually releasing it back. In the same way, what we call I is a process, a collection of ever-changing thoughts, feelings, and memories swirling in the stream of life. There is form and continuity, but no hard boundary where the self truly stops and the rest of the universe begins. Philosophers and spiritual teachers have spoken of the illusion of self. In Buddhism, for example, the idea of anatta says there is no fixed, permanent self, that what we think of as me is just a collection of processes, a candle flame, continuously burning but ever-changing. Modern neuroscience, too, finds no single spot in the brain where a self resides, just networks in flux. When we look for the self, we find thoughts, sensations, perceptions, but no core that stays the same. And yet, something is aware. Experience is happening. It's like a flame. A flame has a shape and continuity, but the fire is new at every moment, constantly changing, yet appearing steady. Our being is like that flame. When we truly absorb this, it can be liberating. The fears and desires that trouble us often revolve around this sense of self, preserving it, promoting it, protecting it. But if the self is more fluid, if we are continuous with the rest of existence, then maybe we can let go of some of that burden. We can rest in the knowledge that we are part of something much larger. Just as a wave realizes it is ocean and thus loses its fear of crashing, we too can find peace in knowing we belong to the universe. We are threads in a universal tapestry, notes in the cosmic symphony, waves in the cosmic ocean. We are distinct, yet not separate. In this peaceful moment, as we drift among the stars in our imagination, you might even feel that boundary of self soften. The usual chatter of the mind grows quiet. We become aware of a deeper presence, a witness that is simply observing the cosmos and observing our own thoughts as they come and go. That awareness itself feels vast, like a clear sky, open and boundless. In this open sky of mind, thoughts and feelings may drift in like clouds or soap bubbles, but we simply watch them appear and disappear without attachment. They rise, they pop, or float away, and the still sky of our awareness remains serene, and unaffected. In that boundless awareness, the distinction between self and universe can fade. You are not just in the universe, you are the universe in a specific location, looking out. As ancient wisdom has long whispered, thou art that. Your innermost self and the cosmos are one. Just as the ocean manifests as waves, the universe manifests as you, as me, as every being, all at once. Breathe gently and feel that unity. The air entering your lungs is the same air that once cycled through ancient forests and dinosaurs, air that was enriched by the breath of ancestors, and that will someday fill the lungs of future generations. The light that falls on your closed eyelids, even faint starlight or moonlight, began its journey in the core of a star, possibly the sun, or perhaps a star from afar, travelling years or centuries to reach you. When you touch the earth, you touch a piece of the cosmos. We are home wherever we go, because we never truly leave the universe. We carry it within us, and we are carried within it. Now, in this expansive state of unity, take a moment to truly feel how boundless you are. Your consciousness is no longer confined to your body or a single point in space. It spreads out like starlight, touching everything. Sense yourself growing larger and more diffuse, as though you are expanding to fill the night. First, you encompass the room or space you are in, then the entire earth below you, holding it lovingly in your awareness. Then you extend outward, embracing the moon, the planets, the sun, and all the nearby stars. In a breath, you become as vast as the Milky Way, with its spiral arms curling within your being. And still you expand. Now other galaxies are like tiny sparkles within you. You are as large as a cluster of galaxies, then a supercluster. Finally, you imagine yourself as vast as the universe itself, an immense sphere of conscious presence that contains all of space and time. In this state, boundaries between here and there, now and then, lose their meaning. Everything is present in the oneness of your awareness. Let us gently unmoor ourselves from the present moment and drift freely along the river of time once more. Unbound by a single lifetime or era, our awareness can roam across eons. Together, we venture forward, far forward, into the twilight of the universe's story, to witness how the grand cosmic play might draw to a close, and perhaps to a new beginning. The stars around us age imperceptibly as we move through time. Millions of years pass, then billions. Galaxies continue their stately dance, but as the ages pile high, that dance begins to slow. The cosmos is expanding ever faster. Galaxies drift farther and farther apart through the growing emptiness. One by one, like lanterns carried far away, the galaxies slip beyond each other's sight, until each is mostly alone in the darkness, an island of dwindling light. The universe becomes a scattering of isolated cosmic cities, each surrounded by vast night. From any given galaxy, nearly all others eventually fade from view, receding faster than their light can travel. Within each galaxy, including the one we focus on now, star formation has long since dwindled. The great stellar nurseries, the nebulae of gas and dust that once gave birth to new suns, have thinned out, having formed generations of stars, and now exhausted their raw material like fields gone fallow. The once sparkling spiral arms grow dim. We find ourselves floating in what was a magnificent galaxy, now grown old and quiet. only faint red stars remain burning, the long-lived red dwarfs that continue to glow dimly after all the bright, massive stars have lived their brief lives and died. Here and there, a white dwarf, the cooling core of a star like our sun, casts a feeble glow, slowly radiating away its remaining heat over trillions of years. This is a dying galaxy, a cosmic city, where the streetlights are going out one by one. Long ago, perhaps this galaxy was a majestic spiral with luminous arms. Now it appears as a faint, hazy smudge, its pattern barely discernible in the darkness. We drift through it, and the view is both melancholy and profoundly peaceful. The hustle and bustle of cosmic creation is over here. What remains is a retiree's quiet evening. Occasional flashes might break the darkness. Perhaps the merger of two dead stellar cores sends out a brief spark, or the last supernovae occur as the very final massive stars explode. But those occasions are exceedingly rare now. For the most part, the galaxy is settled into a deep night. As we wander among these fading stars, we listen to the silence of a nearly exhausted universe. If we concentrate, maybe we can hear an echo, the faintest remnant of all the brilliance that once was. It might be a dim background hum of radiation, the stretched out whisper of ancient starlight that still traverses the cosmos. In this far future, that glow from the Big Bang's afterglow, the cosmic microwave background, is incredibly cold and faint, almost undetectable. The echo of ancient stars also lingers in other forms, a thin sea of neutrinos, ghostly particles that hardly ever interact, still carries energy from long ago supernovae. The very fabric of space still ripples with incredibly subtle gravitational waves from collisions that happened eons in the past. These are the gentle murmurs of a universe remembering its youth. It's as though the cosmos itself refuses to forget. Within the darkness, faint echoes of everything that has ever shone still reverberate. We find solace in these whispers. Even when nearly all lights have gone out, the memory of light remains, etched into the universe itself. Perhaps we even tune into the quiet song of a lone pulsar, a neutron star spinning its final beats, sending out weakening pulses of radio waves, like a cosmic heartbeat gradually fading. To our expanded, timeless awareness, all these faint signals blend into a final lullaby for the dying universe. We drift further ahead. Trillions of years turn into quadrillions. The red dwarf stars, with their miserly consumption of fuel, finally begin to wink out. One by one, these last stars cool into black dwarfs, cold, dark spheres with no light left to give. Black holes, once formed from the collapse of giant stars or residing at the centers of galaxies, dominate the scene now along with these dead star remnants. But even black holes are not eternal. Over unfathomable timescales, they evaporate, emitting a trickle of energy, hawking radiation, until at last they too vanish in a final quiet flash of light. It is a strange thought that the very last visible light in the universe might come not from a star, but from the death of a black hole, as it gives up its remaining energy in one gentle radiance. And then, after an almost incomprehensible span of time, there may come a moment when no ordinary matter remains in our once vibrant galaxy, nothing but thin gas and subatomic particles, so dilute and cold that they hardly ever meet. Perhaps even the protons that make up atoms have begun to decay, as some theories predict over vast timescales, meaning that matter itself gradually dissolves into faint radiation and wisps of ghostly particles. The universe approaches heat death, a state of almost perfect uniformity and stillness. All differences in temperature and energy are smoothed out. There are no gradients left to drive events or time's arrow. It is the quietest of all nights, truly the dark side of the universe in full. In a way, this final hush echoes the one before the first stars ignited so long ago. The cosmos has come full circle in a sense, returning to a profound simplicity and stillness akin to its earliest darkness. Yet we are still here, in spirit, witnesses in this deep silence. We have followed the universe to its old age, and we float in this quiet, cold expanse, embracing the profound peace of the end of time. There is no sadness, only tranquility. The drama of stars and galaxies has played out and come to rest. The stage of creation lies empty and still, draped in darkness. But our journey does not end here. For even in this silence, there is the potential for a new song to begin. Somewhere in the endless dark, a fluctuation flickers. Perhaps it is a random quantum event in the void, or perhaps an echo of an earlier time loop coming to completion. Maybe it is that vacuum decay we mused about, a tiny bubble of true vacuum that appears in the vast emptiness. Whatever the cause, imagine now that a new spark is born. From essentially nothing, a point of immense energy erupts. It happens quietly at first, with no one to witness but us. A subtle glimmer in the void, then a rapid blossoming of space and time. In an instant, that bubble expands exponentially, an inflationary burst like the one that began our own universe so long ago. From the deathly stillness, a brilliant new dawn explodes outward. A rebirth of time has arrived. We watch in awe as a new Big Bang unfolds, perhaps not in our old cold universe, but as a fresh bubble budding off from it, or from its demise. Space-time itself is created anew, and with it, time begins to flow again with a newborn energy. What was a static hush becomes a roaring infant fireball, though we still hear it in silence from our transcendent vantage. In this new universe, light once again flashes forth. Particles come into being. A whole new cosmic evolution will follow. New stars, new galaxies, maybe new life and consciousness, under new laws and constants. It is the ultimate renaissance. The cosmos, refreshed and young, rising out of the ashes of the old. The cycle is complete. An ending has transitioned into a beginning. Just as dawn follows night, the universe has found its morning after its longest night. Time, which had nearly flatlined, now has a new heartbeat. We, as timeless observers, smile at the symmetry and wonder of it all. How beautiful that the story never truly ends. It only transforms. The darkness was not an absolute end, but the fertile ground for a new creation. Gently, with deep reverence, we take our leave of this reborn cosmos, trusting that it will flourish as ours did, and perhaps spawn more wonders beyond imagination. As we depart that newborn universe, we carry a quiet hope that it will blossom with its own stars, its own life, its own moments of wonder. Our journey has traversed the entirety of cosmic history, from the fiery birth of our universe to its silent twilight, and onward to a new genesis. we have travelled not just in space, but in time and possibility. We have journeyed across an almost impossible expanse of wonder. We stood at the dawn of time, witnessing cosmic inflation's furious bloom and the gentle afterglow that followed. We watched matter congeal into galaxies and felt the push of mysterious dark energy pulling those galaxies apart. We shrunk ourselves into quantum foam, seeing how emptiness teems with potential, and we imagined every particle as a tiny vibrating string weaving the symphony of physics. We pondered extra dimensions and universes beyond our own, and danced with the concept of time, seeing it loop and perhaps reset in eternal cycles. We gazed into the abyss of a black hole and dreamed of universes budding within. We learned that our very atoms were born in stars, and that our consciousness is the universe looking back on itself. In witnessing these wonders and feeling this awe, we the observers have given the universe a way to appreciate its own beauty. Now our journey of the mind nears its end. Back in the present, in the gentle darkness of a quiet room or a starlit night, we find ourselves calm and at peace. You might notice the feeling of the bed or ground beneath you, the soft support cradling your body, perhaps a blanket, or the cool air wraps you gently, and you feel the pull of Earth's gravity holding you in a tender, familiar embrace. The grand scale of all we've witnessed puts our everyday worries into perspective. In the face of cosmic vastness, our anxieties shrink and disperse like tiny clouds in a great sky. Even those who have actually travelled into space and looked back at our planet, a fragile blue gem against infinite black, describe a sudden clarity, a sense that borders and troubles vanish, replaced by an overwhelming feeling of unity and peace. We can let our worries go for now. In this moment, nothing is required of us. We are simply here, being, breathing, like a small wave, resting on the ocean of the cosmos. The darkness around us is no longer something to fear. It is the same kind of darkness that cradles galaxies and holds the stars in place. It is a soothing darkness, full of promise and rest. We welcome it like a soft velvet curtain drawn around us, providing comfort and privacy, a space where we can truly let go. Our breathing is slow and natural, echoing the unhurried rhythm of the sleeping universe. With each breath, we sink deeper into comfort. If any tension remains in your body, it softens and melts away, pulled down gently by the same gravity that keeps planets in their orbits. Each gentle inhale and exhale is like the rise and fall of a distant tide. Your arms and legs grow heavy and warm, as if the very darkness around you were a plush blanket. Your mind is unhurried and free. Even your heart beats with a slow, steady calm, each thump resonating with the quiet pulse of the cosmos. As we lie here, on the verge of sleep, your eyelids are heavy and your body is relaxed. We might imagine that above us, through the ceiling, through the sky, the stars are shining down, even if hidden by clouds or the light of day. Their ancient light has travelled years, centuries, millennia, just to reach this spot and caress us. We are, in truth, always bathed in starlight. And just as the stars abide in the vast dark of space, we too find our place in that dark, and it is home. Let the last traces of wakefulness dissolve. Every muscle in your body is relaxing, releasing the day's tension. Your mind is drifting, quiet as a moonlit pond. No more tasks, no more striving, only gentle being. Feel yourself held, floating in an ocean of night. In this tranquility, you are free. Free to let go of today's journey, and free to float in a sweet nothingness. The kind we felt at the very beginning of time, before the cosmos was born. At the edges of your mind, gentle dreams may start to appear like distant stars. You might catch a glimpse of images or feelings drifting in. Let them come and go, leading you softly into deeper sleep. Allow yourself to rest in that feeling. You are not small or lost in this darkness. You are intimately part of it. The dark around you is like a warm, infinite blanket, enveloping you with care. In all the cosmos, there is no other you. The universe, in its vastness, holds you dear as an irreplaceable note in its eternal song. The sense of belonging you feel now is complete and comforting. In this sacred quiet, let your consciousness dim like a gentle fading star, easing you into the soft night of sleep. Just as a candle flame flickers out with no fuss, your awareness narrows to a calm, dark point, and then even that melts away into restful nothingness. All that remains is a deep, healing silence. As you drift off, perhaps a last image flickers in your mind, a view of countless stars turning slowly, galaxies blossoming and fading in time-lapse, and a feeling that all is well. You carry this peace with you as you step over the threshold into dreamland, like a small piece of starlight kept in your heart. In sleep, your journey will continue in its own magical way. Maybe you'll find yourself gliding through a nebula or conversing with an ancient star. Whatever dreams come, let them gently unfold, knowing you are cradled by the universe at every moment. Here at the end, we arrive at the same place we started, the quiet darkness. But now it feels full of friendly stars and endless possibilities. In this union, you are profoundly safe, wrapped in the gentle embrace of the cosmos. And as you surrender to sleep, you become one with that serenity. In this union, you are profoundly safe, wrapped in the gentle embrace of the cosmos. Good night, and sweet dreams among the stars.